It's up to you. You don't have to have.
Oh, I don't have a Mac.
Do you have something with a Unix shell?
No.
You don't have a Linux laptop? You don't have a Linux emulator on your Windows box?
No.
How do you use it? Is it like?
I write programs.
Okay.
That's all I need.
That is a big lens.
Which one? You're Disney?
Yes.
Oh, cool. I'm with the college.
Awesome. It's all good. It seems like the stream of people coming in is starting to taper off. All right, I'll start. Welcome everybody. Thank you for spending your Saturday with me. I mean, you know, getting up like early on Saturday and doing anything that doesn't involve like, well, you guys, a lot of you are still in school, so you still have to do homework, huh? But not Saturday morning, right? Little background, I went to Cal Poly San Luis Obispo. I studied computer science. When I was in high school, I was like, I totally want to study journalism. I applied to Cal Poly San Luis Obispo as a journalism major and did not get accepted. So I went to junior college, and I went to junior college for several years, and I started taking these computer science courses. And this was in like the mid-1990s. And we did have the internet, and we had email back then, believe it or not. And I started taking these courses, and I really liked them. And I kept taking more. And back then, it was very C++ focused. Pascal was still a thing. We didn't have Python yet, which is very sad. And I really enjoyed them. Cal Poly San Luis Obispo back then was predominantly a Unix-based school. So the entire computer science department was Unix-based. We had, what did we have? We had HP graphical workstations, and we had dumb terminals. You guys have probably never even seen a dumb terminal, huh? All over campus we had these dumb terminals, and what these were is we had a HP mainframe, and we would walk up to these dumb terminals, and this is where we did our homework. And they were just a terminal where you type Unix commands. And we did our homework, and we did all our programming on these dumb terminals with no graphical user interface whatsoever. 80-column displays. And I loved it. I got to take Fortran with a line editor and take all these courses that probably just don't exist anymore. Java wasn't a big thing yet, so we were C++ based for all computer science courses. And so I think I had a Windows machine at home for like playing video games, but that was all they were. I got my computer science degree from Cal Poly, and this internship popped up doing, of all things, Lotus Notes development at this part of Disney where they had Windows. And I was like, okay, I can learn Windows, right? I use it at home for games. So I did that for a little bit, and then a position opened up in animation. And I applied for that, and I got in, and my first film that I worked on was Disney's Dinosaur. I don't know if you guys have seen that. It's like live action backgrounds with CGI dinosaurs. This was my first film credit. It was very exciting for me, you know. Cal Poly computer science grad, and my name's in the movie. It was very exciting. The cool thing is when I got to animation, it was like I was back home again. I got this job, and they put an SGI IRIX box on my desk. And like we had SGIs at Cal Poly, and it was like very familiar. And over the years, I supported many different kinds. We had all Sun machines in the data center back then, so I used Sun Solaris, and I worked on Cray Unicos, and HP UX, and IBM AIX, and all these different flavors of Unix that existed back then. And then we moved to Linux. And we are still today predominantly Linux on the desktop. Most of our digital asset creation happens on Linux, running a combination of proprietary in-house tools that we write in-house. We have many software developers in-house, still mostly C++. And we also use a lot of third-party tools that are available on Linux. Maya is available on Linux, Nuke is available on Linux. So we're still Linux on the desktop. So we still have artists who come in and they get a Linux box on their desk and they work in Unix. As years went on, I worked on many different projects, really enjoyed that world, and an opening came up on a Mac team. And before I was like, what do you do with a Mac, right? Like, I can't really play games on it, and it doesn't have a Unix shell, and I couldn't figure out what you do with them. And then OS X came out, and this was like, oh my frickin' goodness, we have Unix on the Mac. Suddenly the Mac became interesting to me as a Unix guy. So I said, hey, I'm gonna go join the Mac team, and I moved and I started doing Objective-C development in Xcode on the Mac, and it was quite an adjustment. Learning that the command set's a little different, the way you work is a little different, and oh my goodness, click to focus, what's that? Like I was used to mouse over focus, like all these little things. But over time, I learned to do that, and I really enjoyed it. Then the years went by, and I moved into management. I started managing an HTML5 development team, and then some positions opened up managing an IT team. And this was like a big change, because I know no one likes to raise their hands in presentations, but do we have a lot of computer science people? Any? Couple, and the rest are too shy? Any people who are like totally not in this world at all, like you're studying either English or history and you're like, what in the world is Matt talking about? Too shy to raise their hand again. Okay, that's fine. Does everyone know what Unix is? Okay, and most people know what a Mac is. So we're okay so far. They're all like, no, I do Windows and Java and I don't know any of this stuff you're talking about, Matt. And that's okay, like we embrace everybody, it's fine. Okay. So, as I started doing this and supporting these crowds, I found that there's this interesting thing where there are people now who have spent much of their career clicking on GUIs to configure stuff and deploying things. Like the tools now have gotten so good and the configurations have gotten so good. There's a lot of stuff you can deploy just by reading a manual, going to a GUI, some web page that configures something, you click a bunch of stuff and out it goes, right? We just got the Mac here talking to their thing here, and it was all just click through. Didn't have to write any code. And I found that when I got more working with the Mac IT people, a lot of them had spent their whole career this way. Like the Mac had been so good for so long, they had been supporting this platform and had never had to write any code. And as a Unix propeller head guy, this was really weird to me. It's like, how do you do that? But it was also clear that there was this amazing power you have here with this Mac, because you can just open terminal and you have like a full Unix shell there. Like they went to Hogwarts and didn't learn any spells at all, because all the good spells are there in the terminal, right? So I put together this presentation. That's what that presentation I have today is. It was designed really for Mac IT people who had spent a lot of their time clicking GUIs and configuring things, and to kind of expose the power that's available in the terminal. So I cleverly titled it the 12 Unix commands everyone should know. I mean, I thought that was clever. It's like, nerds, it's fun. We're only so good at funny. But I titled that, and that's what I'm going to talk through. So is everyone still interested? Yes, okay. Some were like, I still don't know what you're talking about, but it might be interesting, so I'll stay with you. Okay, thank you. Okay, I'll start with some sizzle. And I guarantee everything after this video will be more boring, but if you're sure you're in the wrong room, at least it gives you a chance to like walk out. This is a video our recruiting team put together, and I like this. I get a little choked up every time I watch it. It's a bunch of our technical leaders at Disney talking about technology at Disney. Ed Catmull's voice is in here. Do you guys know? No one's going to raise their hand. It's too shy. It's okay. Ed Catmull is the founder of Pixar. He also, I think he has a PhD in physics. and he invented a lot of computer science, like graphics algorithms that are still used today, like cat-ROM and stuff. So he was really a founding father of computer graphics. Then he went off and founded a computer graphics company. Okay, a little more Disney history, because we're tying this. He formed a company called Pixar. Pixar started out as actually making imaging computers. They were a computer company. You could actually buy Pixar computers. Disney, back in the 1980s, was making 2D films, right? Not computer graphics at all. We had like people hand inking and painting cells. And they got this idea like, boy, this is really labor intensive. What if we could do this in the computer? Back up a little more. There was this innovation Disney came out with in the 30s, which actually won an Academy Technical Award, called the multi-plane camera. So if you think about, you got a cartoon, you got a character here, it's on top of background, you take a picture, and you move the background a little bit, and you run an animation cycle, and it looks like the character's running across the background. What if there were mountains in there and trees? All these things are going to be moving at different rates, right? The trees next to you are not going to be moving as fast. What if you want to show some depth? What if you want to truck into the character? All these things should move at different rates. So Disney in, I think, the 1930s came up with this thing called the multi-plane camera. And it was this big thing where you put a camera at the top and had all these levels in there, and then that you would take a picture, move a bunch of knobs, take a picture, 24 frames a second in an animated film, 24. So you take 24 pictures for 1 second of animation. You'd load different backgrounds in there. This was really labor intensive. All of these are hand painted. So in the 80s, they were like, you know, computers are starting to be like useful and stuff. What if we, they probably didn't say it that way. What if we had a way to do this in the computer? They invented a computer animation system called CAPS. Computer animation, what was it? Animation production system, something like that. CAPS won an Academy Award, which is pretty cool as a programmer, right? The people who worked on it back in the 80s, like got Academy Technical Awards. They did this in partnership with a small computer graphics company called Pixar. So actually Ed's been involved with Disney for a really long time. CAPS was how we made a lot of our films. You've seen like Treasure Planet and Atlantis and Home on the Range and it was used for a little bit on Little Mermaid, but Rescuers Down Under was the first film to use it. So Lion King, Beauty and the Beast, those were all CAPS movies. They were all done in this computer system where they could ink and paint in the computer. And it ran on these Pixar image computers. So that's a bunch more Pixar history than probably that you might have been interested in, but give some background of who it is. So his voice is in here. He's listed as Ed, as well as Michael White. Anybody go to Google Next? Probably not. Google had a conference recently. Michael White was one of the speakers, so he's in the video as well. We did get more people. It's awesome. All right. Enough intro.
And now your host, Walt Disney.
In our modern world, everywhere we look, we see the influence science has on our daily lives. Discoveries that were miracles a few short years ago are accepted as commonplace today. Many of the things that seem impossible now will become realities tomorrow.
Technology is what powers the magic behind Disney.
Great new discoveries have brought us to the threshold of a new frontier.
Beautiful tomorrow, just a dream away. Here we go.
Technology is part of the DNA at Disney, has always been part of the DNA at Disney, but it's always been in service of telling the story.
If the guests walk away talking about the technology, we haven't done our job. It's all about the experience.
I care about creating technology that really builds wonderful experiences, and I think there is no company where you can do that in the way that you can here.
Pixar was born, and Disney, more than any other company, realized the value of technology to the entertainment business.
People don't realize that we are the magic that they see on screen. We're the magic that they see in sports. We are the magic that they see when they come into the park.
There's so much passion on the part of all of the teams behind what we do to make sure that what we're building lives up to that Disney expectation
We're looking at interactive entertainment, ways we can create more personalized experiences so that guests can participate in these immersive worlds.
Watch ESPN, ESPN.com, any of our mobile applications.
In the rendering group, we try to understand what gives objects their color, their appearance. And once we understand it, we write programs that mimic this behavior.
With a big idea, there is very little friction in making it into something through the use of technology.
From movies to TV, to parks, everything your imagination can come up with, this company has for you.
You're not only working with all these wonderful products and brands, you're working with different business segments, and each of those create great opportunity to really have multiple careers within one career.
Our goal is to set new standards that everybody else would be looking at and go, I can't get there.
That to me is really super exciting as a technologist, to continue to move at the very front edge with the technology in so many different areas.
The ability to see our guests smile as a result of the product and capability that you built, it's just blissful.
During the last few years, we've ventured into a lot of different fields. We've had the opportunity to meet and work with a lot of wonderful people. We hope that you will join us and that you will find here a place of knowledge and happiness.
We're creating magic, literally, using technology. It's an exciting place to be.
Oh, that was really bright. Did I need to turn them all on? Actually, I don't know how this works. Did you figure it out? All right, any questions? So that was kind of a mix of like many different groups at Disney. Disney's a really big company. So the division I work for is animation. We do the feature film production, things like Frozen, Big Hero 6, Zootopia. Did you guys see Zootopia? Somebody saw Zootopia. Thank you for watching Zootopia. We're working right now on Wreck-It Ralph 2. Takes about 4 years to make a film. The first parts are, which means we're working on the next 4 years for the films now. We start with a story process, so and that's where the film spends most of its time, is working out the story. So we have story artists who work on sort of a hand-drawn story process, which is still it's still digital. And we add audio to that, and we can screen the film over and over and over without actually having to do any animation. Just watching story sketches and getting a feel for it, and these films will get iterated on that way for years. At some point, the story starts to come along, and we start to say, okay, you know, that's the one story we think we want to make, and then they start producing digital assets. By digital assets, I think models and textures and sets, backgrounds, you know, kind of the digital world that they're going to animate to. And then kind of the last year or so is the actual production of the film, actual creating the what you're going to eventually see on the screen. So it's a lot of different people of different backgrounds working together. Okay, so are we ready to get into the more technical stuff? Any other questions to distract me before? No? Okay. So.
You can tell us about Wreck-It Ralph 2?
It's going to be awesome.
Any caveats to look out for?
It's going to be awesome.
What part specifically in the animation process do you work on? Because I know it's a bunch of different aspects to it.
Yes, yes. My entire time at Disney, I've been in technology. So there is sort of a crew that'll be working on the main film, like the next up film, and there's a bunch of different disciplines and a bunch of different roles in that. And then there's usually some people working on the next film up. There's also sort of a foundational technology group, and what we do is everything from traditional IT, like networks and email and login services and desktop deployments, all the way up to very custom specialized software used in the filmmaking process. If you think about when you're working on a film, your focus is going to be on what you need to do for that film. So Moana, we had a lot of water, and there were people very focused on creating stuff specifically for Moana and that water. The people on the film will be focused on the needs of the film. Technology is going to be looking across films. So if we're, for instance, years before Moana was going to be in theaters, we were like, okay, Moana's going to have a lot of water. We need to get better as a studio at creating water. So the technology department, the foundational kind of technology department, will work on things that for the not, they'll be working on the current film, but things for the next film and the film after that. And that's where I am. I've had several different roles there. Most of my time has been an application developer, creating tools for the artists. About a couple of years ago, 3 or 4 years ago, I moved over to what you might call the ops or IT side of the house, which has been like a totally different world. I do enjoy it. So now I manage a team called Infrastructure Services. And it's things like LDAP and single sign-on and MDM and all these things, these boring foundational things. But I enjoy both. I enjoy both. And that's kind of the neat thing about technology. It's a very diverse field, and there's a lot of specializations. And I don't know about you, but like I tend to get bored with something after 3 or 4 years, and like I want to do something different. So, and then there's like this opportunity to like totally learn new stuff. And so yeah, that's where I am now. Other question?
What are you learning now?
It's interesting, you know, being a developer, and moving into kind of what you'd call the ops side of the house. You know,
leaning more towards DevOps, is that the direction you're?
That's where I am right now. Yeah. Yeah.
Is that the new thing you're learning, or is that where you're starting from and learning something else?
The last few weeks or last couple months have been a lot of about corporate security guidelines. It's really kind of exciting. No, it's not. But it's okay. It's interesting because when you're on the outside of the house, you're now responsible for all of these deployments of, you know, how do we make sure no one hacks into someone's phone or someone's desktop or someone's laptop. Were you guys all aware of the big Google worm, I guess I'll call it, that happened a few weeks ago? It was pretty exciting. Nobody got caught by that? No? But that's the kind of thing my team will jump on right away, something like that. Where so what happened, there was a Google, we'll call it a worm, that happened a couple weeks ago where you'd go in and someone would click an email, it would say someone shared a document with you, the person clicks on it, and it says this thing would like access to your Google account, and then if you clicked it, you granted the virus full access to your email, and then it would look up in your address book and mail all your friends. Spread real quick. Google shut it down. It was actually amazing how well Google responded. But it's a very different thing than when I was a software developer, just kind of focused on my code and focused on my users that needed bugs fixed. Did I answer your question? It's much more like, you know, as a developer, it's not very often you're like dropping everything you do because the studio's getting hacked, right? So this is a very different kind of thing.
So with that being said, are you worried about the WannaCry ransomware that's been hitting all over the globe?
There's a certain nice thing about not having Windows in your environment.
That's definitely one of them.
Yeah, not that, you know, we're ever going to be, you always have to be diligent, right? If you're in finance is always going to be on Windows, and they have important data. So yeah, we got to watch for stuff. But it is nice being Linux on the desktop. All right, I'm going to try presenting from here. So again, the reason I put this talk together was a lot for, when I got involved in the Mac IT world, I found that a lot of people had been supporting the Mac for a long time and had never used the terminal. And so they're missing out on all this power. So I gave this talk at a couple conferences. They were Mac IT conferences, mostly talking to Mac sysadmins, system administrators who may manage Macs. There's a lot of Macs deployed out in industries. I was talking to a lot of big tech companies who have pretty large Mac deployments, and there's a lot of work involved in managing those. So this was sort of to kind of get people used to using the terminal. Some of these commands are Mac specific. So if you're working from a Linux box, they won't work. If you're working from a Mac, they will. But those are the 12 I picked. I do have all the code I'm going to show today and all the examples on GitHub. So you can git clone that or go to that URL and download it if you want, and download a zip file. And if you have a Mac, you could download it now, and then you could even follow along if you want. Or not. I easily could have called this like 50 Unix commands you want to know, but then the talk would be too long and you'd be really bored, so I didn't call it that. I had to kind of pick 12, and if you are like a Unix person and you're thinking, well, how come you didn't cover command blah, 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 it's because I just had to pick 12. And I kind of picked the ones that I thought would help kind of build a foundation. All right. For the people that have Macs, I'm going to ask, how many people actually use the terminal? Anybody here? Yes. Okay, so we have a few people that are comfortable with it. For those that aren't, is it showing what I'm doing here? Yes. Go up here and you type terminal. And that is a full Unix terminal. Is there anyone that's completely new to, that doesn't mind telling? Okay. No? Okay. So the people that is new to don't want to tell me, and that's okay too. One thing that was new for me when I had to move towards using the Mac is when I was in Unix land, when I had like a Linux box on my desk, my hands didn't have to leave the keyboard very often, right? Because you're working in a terminal, pretty much everything you need to do, you can just type it. Then I got to the Mac and I'm clicking on all these things, right? And there's a time penalty, right? Every time you move your hand from your mouse to your keyboard, there's a little bit of a time there. If you've only used a laptop, you don't know what's a mouse, right? But one of the nice things, and again, where this helps people sometimes, is realizing there's a lot you can do just in this window. Okay. Another nice thing about working in a terminal is there's this thing called manual pages. People who know this are just like, yeah, I know Matt, and the rest of you are like, what's this thing? So I'm going to show you. So I'm here in the terminal. I'm going to show you this command called open. And if I type man space open, documentation. Isn't documentation awesome? Except nobody actually reads documentation, right? Is that, no? Yes? Okay. It's an interesting thing, this for software developers, we always have these debates about documentation, right? Because everyone agrees you should do documentation, except you do documentation, and as soon as you do it, you do a new software release, and all your documentation is out of date. So whenever you create documentation, you have to maintain documentation, and no developer likes maintaining documentation, so they just never do it. So usually when you find documentation, it's like way out of date. Like everyone's experiences, right? You've gone to read some manual on something that's like, oh, we're out of date. The man pages on Unix are pretty good. I'm guessing they have something that generates some of this based on code. So you put your documentation in your code, you have something that sucks that out and builds documentation automatically, so you're forced to maintain the docs with code. It's like totally like, okay. I can tell by the blank stares you guys haven't had this problem before. You will someday if you decide to go into technology. So open on the Mac. So this is the gateway command for Mac people who have never used the terminal because it allows you to open stuff, run stuff from the terminal. So normally, let's say I wanted to run Safari on the Mac. I might have it down in my toolbar, or I might go applications. Am I looking right at the applications? And then I go and I find Safari, and then I run it. With open command, Q. Okay. I think it's meant, okay. Maybe I'm the only person that gets really excited about that, but I think that's super cool. Oh, look, it's a commercial for the iPhone 7. Okay, goodbye Safari. Okay, so that's the open command. The open command will also, it's kind of smart. So if I type open and just type applications, it'll open up a Finder window with the applications folder. And if you have your Mac, you can actually follow along with this. I can open a path. So if you ever had to browse around in Finder, or if you're using Windows, what do they have? Windows like Explorer or something? Mm-hmm. Like you have to click this, click that, click that. No, you just type the path. Type open in the path, and then it opens up a window in that path. It's magic. So I ran Safari, you can run applications that way on your Mac, all working in the terminal. You can open a URL. So if you type open space and then give it a URL, it's smart enough to know that's a website, and it opens a web browser with that site. Cool. Yeah, you can open an image. So it'll, if you give it like, in this case, it's essentially a data file, right? It's a picture. It'll open, I think, preview and show you the picture. So instead of like going, browsing to it, double clicking on it, you can just work completely in the terminal, hands on the keyboard. These are all examples that work. There's something I did on purpose here. I picked paths with spaces in them. So if you're not like a Unix, like you grew up on Unix, when you were a kid, that's all we had was Unix. Like putting spaces in names was like a really evil thing to do, because the space is like a separator, right? So you don't put spaces in the name of anything. Like it's like kind of like a crime or something on Unix land. And I get to the Mac and there's these spaces in the name and my head totally blew up. Like I was like, I just can't use it. But that's why that backslash is there. It's called an escape. And so you escape out the space. Otherwise it won't work in the terminal. The terminal will see that space and think it's a new thing. So it would try to open library desktop, and then it would try to run pictures frog, which wouldn't exist. So you have to escape out your spaces when working in the terminal. Or you could do that second trick that I did and just put quotes around the whole thing. And for people who have never worked in a terminal, they're probably like, really, that's a thing? Don't you just click on it? Like, it just works, right? Didn't used to. So. Go ahead.
Question. So I usually use Linux, so I'm just familiar with the terminal. What's the benefit of using the open command versus just using the path that's directly for, say, like Firefox, or is that just not built into the terminal on Mac?
Open adds some smarts, and so you've used the Mac. So the Mac paradigm is to put applications into the /applications path, and not to put things in user bin or user local bin and then put them in your dollar path.
Oh, okay.
So if you're normally a Unix guy, you're thinking, yeah, just type Safari or type Firefox, and Firefox is in wherever it is, user bin or something, and it's in my path and it just runs, right? Mac usually doesn't do that.
Gotcha, because they're not intending for people really to use the terminal.
They're not intending for people to use the terminal. And you actually bring up a really interesting thing, that this happens quite a bit with people who are Linux developers who now go to the Mac, because they're very used to working this way, right? Like, why wouldn't I release my software to user local bin or user bin and put all my libraries in user lib64, right? That's where you put stuff, except on the Mac, they don't, it's all about application bundles. And going to applications and double clicking things. So there's this discussion you usually get in about where you put your dependencies. And people who aren't software developers or have done software development in a large environment probably aren't used to thinking about this. But whenever you write software, you're probably going to be reliant on other people's software. And when you put your software on that computer, you don't know if those other people's software is going to be on that computer. So how do you solve this problem? Well, one, you only use stuff that you know ships with the machine. That will usually work. Except that's usually too limiting for most people. You're going to have dependencies that you carry along. And the way you handle dependencies on Linux is you just install everything to user lib64, and run stuff out of there, right? All your SOs are there. And I apologize if I'm getting too technical. But on the Mac, it is more about app bundles. So you kind of tend to bundle all your dependencies in it, and then you can take your software and drag it there, and all the dependencies come with it.
Okay.
So it probably gave you more than you wanted.
No, that's actually kind of exactly what I wanted. To be perfectly honest, I was, for a while always kind of not against Macs, but never used them. And it was when I went to Scale and I saw all the Linux admins walking around with Macs, and I'm like, what the heck? And then I realized, oh yeah, it is a bash terminal. You can just manage everything through SSH, and it has most of the same commands that you're familiar with on Linux.
Yep, exactly. And where you get is all this other, like, the Mac-isms. Right, because you'll be like, I want to release this thing to the Mac, and then I can't put my dependencies here because of system integrity protection, and then now I can't install my so yeah, app bundles. App bundles. Okay, and it also allows you can specify an application. So if you say I want this thing to open in Safari, nope, I want to open in Google Chrome. It's smart. Open's pretty powerful. It's the gateway, they say gateway drug to using the terminal, right? Like, hey, wow, that I can actually do real stuff. Okay, disk-util. This is another Mac-specific command. And this allows you to, again, I originally put this talk together for Mac admins, and there is a graphical disk utility on the Mac that they're probably used to going and clicking on. Kind of like I was saying, there's a lot of administrators out there who have spent their whole career like clicking on GUIs and doing stuff. Well, you can do this from the terminal too. And since this isn't a bunch of Mac people, I'll just kind of continue on through this. But you can see disk partitions and things like that, probably stuff that unless you've had to ever build machines, you don't care about disk partitions. All right, LS. LS is like single most used Unix command ever. And it's super, super powerful. And everything here works pretty much the same whether you're on a Mac or whether you're on a Linux box or whether you're on a Sun Solaris machine. LS means list. It lists the directories of a path. So you type LS and you give it a path and it'll tell you what's there. So, ls/volumes. Is that too small? Command plus. ls/volumes, and I can see whatever's in /volumes. ls/applications, I can see all the applications installed on the machine. Pretty powerful. And the nice thing about this command is, you know what, let's see, if I go over here, they built this VM for me. Is that visible? So now I am on a Ubuntu Linux box where you can't see the whole screen, which kind of makes it not that. What was it? Control-Shift-Alt. They gave me a cheat sheet here, except that doesn't work. Well, that'd be a pretty lousy demo if you can't see the whole screen, huh? Yeah. Huh, okay. Well, if you could see the screen, you'd see that the commands.
Would it help if I turn off some of the lights?
Oh, there.
Oh,
Okay.
the size, it's like over. Oh, no, it's actually. No, it's good now.
Well, yeah, so you can see except the. There we go. I did ls/. So same command, whether you're on your Mac or whether you're on Ubuntu Linux. Same power. All right. So you do. Oh, I need to go back. Okay. Yeah. Okay. Good. If you do decide to download the code and try it, the little green letters in the bottom are the actual like script I'm working from. So if you're like, oh my goodness, this shell stuff's amazing, I want to go home and learn it all, you could go and download my code from Git and take So you have these paths on the Mac. Remember when I talked about spaces? So the space on the shell is a separator. So I did ls, I put one path, then I put another path, and then I put another path. The shell is what separates those apart. So actually when I went to Cal Poly, I had to write my own shell. Like that was a thing back then, and we actually had to write the code to break this up, and it was all like string token stuff in C. You guys probably don't have to do that anymore, huh? You guys doing Java? Did anyone? I'm sorry. It's okay. It's okay. So the shell is going to take those, it's going to break that up, and it's going to run on it's going to list 3 separate paths. So, no, let me just show you, because otherwise it's confusing. Okay, what did I have? ls, user, bin, user, bin, and user lib. Are those ones I did? So it lists all 3. So it's smart enough to break that up into 3 separate things and run across them. So you can imagine when I came from Linux, and I was used to working this way, with spaces being a very important thing because it breaks up commands, and then finding like names of things with spaces in them. I was like, how do they can't do that? That's not allowed. There's no crying in baseball. Okay. I put a star on the end. Is that weird to anybody? What the star might do? Yeah, he's like, yeah, I know that. That's a wild card. So the star will go and match everything with a pattern. So that's called a wild card, and you probably have seen them someplace else if this is all new to you. If it's not new to you, you're like, yeah, dude, Matt, I get it. Okay, so ls user sbin. So I see this path here, and there's a whole bunch of stuff in here, and I'm like, oh my goodness, that's too much, right? I just want the things that start with a P. P star. They're just the things that start with a P. Wildcards, super powerful. Fortunately, this concept holds up in a lot of other places. There's a lot of other things that work this way. So this does matching for you. So give me just things that start with an I, DI. Wildcards. For people who've never used the shell, they're like, wow, that's pretty powerful. It's like search built into this thing. You can also put them like in the middle, so it'll find things where you have patterns in the middle. So this kind of takes you this transition of thinking things in a slightly more generic way, right? Thinking about there could be a bunch of characters in between there, and it will match differently. ls has a bunch of options like -1, 1 per line, ls-l gives you a long listing with more details. Okay. I threw another special character at you. I threw a tilde. It's not because we're going to make pinatas, and pinatas are cool. That's like the most common. Like, they have tilde. On Unix, the tilde is a special. Actually, we'll do it over. Let's see if we can go back over to our other one. Where is it? It's here. Here. Still goes off the end of the screen. ls tilde. Is there anything in the home directory? It's going to be really boring if there's not. There's nothing in the home directory. Yeah, I'm going to touch a file. Touch my file, which I think I just typoed. Yeah, no, I didn't. ls tilde. My file. So pretty much Windows and Mac have this as well. They have this sense of having a home folder or a home directory. The tilde on Unix, both on the Mac and on this Ubuntu box we're running here, is always going to be your home directory. You can do things like question marks. So that's like any character. So this would be give me DS and then any character. You can put multiple question marks. So if you see, I'm trying to show this, like, it's pretty powerful. Like the amount of different kinds of searches and different kind of combinations, things you can do. And you can do this all in the terminal, and it all ships for free with your machine. They're all looking at me like, Matt, you're on the wrong thing. Yeah. Last thing there is what's called a regular expression. And there's nothing really regular about them. They're really complex. And when I was in college, this was one of the things that drove me nuts whenever I had to do regular expression for my homework. Now I've gotten used to them and learned to live with them, and they're really good friends, and we take walks together and everything. Regular expressions are super powerful, and they do exist in other places, not just in computer science, not just for programmers, but they're very useful if you are in those places. And this will search for any 3-letter command that has A through Z in it with no numbers. You want me to demo it? Not really, I'll demo it anyway. Okay, what did I do? I did ls user sbin. And there's a bunch of stuff in there. So what if I did ls user sbin A through Z, A through Z, A through Z. And that gives you everything that had 3 letters A through Z, right? Let's do it with ls-1. So some of you are either saying, oh my goodness, I'm so glad I didn't study computer science, right? And some of you are saying like, wow, I wish I had that on my homework because that would have been useful. Regular expressions. You guys are excited about regular expressions. Okay, I'll move on. And it's going to start at the beginning of the slide, isn't it? Yeah, that's all right. In Unix, this whole environment, the way the file system works and the way the environment works is a standard called Posix. It was established like in the 60s. It's still very much alive today. This is running under the hood on your Mac. It's running under the hood on your Ubuntu Linux box. It's not running on your Windows box. They actually moved away from Posix when they developed, DOS and Windows in whenever that was, the 70s. Posix has a sort of simple permission system where there's 3 kinds of permissions. Do I talk about that here yet? No, I don't. I won't go too much into it, but if you're working on the Mac, it's important to know that you're still sitting on top of a Posix file system in some way. There are commands to do things like change permissions. So one's called chmod. Does anyone ever have to deal with binary anymore? No? Yes. Somebody. So the chmod command can change permissions on things. You can actually give it numbers, and it comes down to a bit mask under the hood. Where you have to, if you know binary, it's really powerful. And this is a chart that can help people, but since it doesn't feel like we have a whole lot of people here who are excited about it, I'll breeze through this kind of quick. Yeah. Come on in. We're really friendly. Okay. We're friendly, right? Make sure I got it right. Okay. So if you really want to learn these permissions, and if you really want to learn a quick way to do it, you could learn how these maps work, and you can change permissions. I'll just touch on Posix permissions because I think they're cool. In the old Unix world, you had 3 levels of permissions. You had, and everything you had, whether it was a file or a directory, it had these 3 levels. It had what you, the owner of it, can do, owner. what your group can do, because everybody's in a group. So you'd create an account, that account would be in a group, and then you had what everyone in the world could do. So you only had 3 levels, user, group, world. For user, group, world, you had 3 levels of permissions. You had, can I read it? Can I write to it? And can I execute it? And that was it. User, group, world, read, write, execute. Yeah, there's some other things like sticky bit and set UID and stuff, but we're just like, basically user, group, world, read, write, execute. So every file on the computer had to have these 3 permissions set. And remember, when I was at Cal Poly in San Luis, we were all on this big mainframe. So you would log onto this big computer and there'd be like 100 students on there. And we were all in the students group. So if you like gave write access accidentally to your entire group for your homework, you just don't know what might happen to your homework. And so this was a really important thing to learn. And if you open a terminal on the Mac, this is all still there. You can go and change permissions of things on the Mac and very quickly affect whether or not someone can run something. Directories have to be executable to list them, so you can make accidentally or on purpose, make directories not listable or not writable or things like that. Posix permissions. And there's also sort of this simpler way of doing this, like chmod arwx, takes everyone and makes it so everyone can read, write, and execute a file, things like that. I'm going to do a quick demo of that. I wish I could get that whole window display on the Ubuntu box. That would be really cool because no, where's the what is that? Okay, I give up. Oh, there it is. No. Okay, fine. I'll just do it from my machine. Oh, really? Okay, remember ls? It's your friend, list whatever's in the directory. I'm going to make a file here, and there's this nifty command called touch, and I'm going to call it test file. I can see test file here, see these permissions? That means I, the owner of it, can read and write to it, and my group can read and write to it. So if I was back in the 1990s at Cal Poly and I had created this file with my homework in it, someone in my group could have gone and written to it and changed it. And so I can say, you know what, I want only me to be able to write to this. So I could do, let's see, chmod group minus W. Yeah, it's not chmod. No, I never do it this way. You know what? Wait. There. Now I can see this has read and write, and read for my group, and read for the whole world. What if I say, you know what, I just want to let anybody write to it? Now it's read, write, read, write, read, write. So it gives you a little exposure to kind of Posix permissions and how this worked and how it still does under the hood on a Mac. And again, if you're going into Unix world, super important stuff. If you're like, I'm just going to be a Java developer on Windows, this is super boring. Okay. If you're like, I don't know, come up with another scenario. Okay. So, but these all have, oh, that's what I liked. I didn't take out the space. Both of these methods work. Okay. Move on permissions. Everyone's bored with permissions, I can tell. It's okay. More examples on permissions. Okay, change ownership. Another nifty command if you're working in the shell. You can change who owns something. There's kind of limit on what you can do for just a normal user, but you can actually change who owns stuff. So again, we're in permissions land of files. Oops. Okay. I threw something in there. It's kind of interesting. When you're working in a shell, there's this whole environment that comes along. This was one of the big things that was kind of weird for me when I switched to the Mac. When you double-click something in the applications folder on the Mac, however that's configured has to be in that application bundle. There's not a lot of sort of global configuration that comes from the Unix side of the house on the Mac. But if you're like on Ubuntu Linux or really on any Linux or any Unix for that matter, you're working in the shell. The shell has its own configuration. So there's things called environment variables. And it doesn't mean like the temperature changes during the day. If you didn't, yeah. They configure how the environment works. One of those things is $user. You can actually poke around and look at these. So this is my login on this computer. $user is who I am. You can leverage those things if you're working in the shell to actually do stuff. So I could do like own test file $user and where did I did it backwards. And that would change ownership to $user. So if you were someone who was getting into shell scripting, this would be useful to you. Do you disk usage? How much space am I using on my hard drive? DF, how much disk space is free? Again, you can be in the shell, changing permissions of things, seeing where stuff is, running commands, figuring out how much space is on your hard drive, all without your hands leaving the keyboard. Pretty cool. Okay, it's just cool to me. It's all right. Some examples of doing DF. Find. So you're working on the Mac and you're really used to this spotlight thing where you click up in the corner. And Windows has something too, right? Where you can kind of just search and find commands and run commands. The shell has its own command called find. So you can actually type find and it'll search through and find stuff. This was always a big thing before I knew it. Like, how do you find where something's installed or something is? For instance, if you didn't know where a terminal was kept, you could do find and give it the name of the thing you want to find it and find it for you. And it'll also do searches like on time. So like you ever try to go on your computer, tell me all the files that were modified in the last 3 days? Like how would you do that if you want to do that right now? If you have a Unix terminal, you can just type that. So this is like things that were modified in the last 5 days. So this would give you, you're going to find in the application folder of everything that was modified in the last 5 days with the name of .app. That'll give you all the apps changed in the last 5 days. So if you're like, I don't know where the last version of my presentation is, and I know it's somewhere on my computer, and I know I modified it in the last 2 days, you could do a find of slash of everything modified in the last 2 days, and then you would have a listing of that. So pretty powerful working from a terminal. Symbolic links. I threw the little tilde in there again. Remember, that's your home directory. That's secret talk for my home folder. So this would find me everything that's in my home folder that's a symbolic link. Symbolic links are how you can create links to files. You can have like well, there's like a really big file out here and I don't want to copy it in because I don't have enough space, so I can like link to it. So Posix thing, it's pretty useful.
Excuse me. When you say looking for the file in the last 5 days, is that only for the on the computer or could it search a network?
It's whatever path you put. So you could have network volumes. So like on Windows, those are like lettered drives, right? You're not going to have that. Posix land, you would most likely take that drive and mount it as a path. So on the Mac, you'd probably put it under /volumes. So if you have a file share on Windows, like some network share out there, you might mount it as, I don't know, h:/my file share. On the Mac, you'd probably either mount it under like /volumes my file share, or you can do what's called NFS and actually mount it pretty much anywhere. And then, yeah, if you use the find command against one of those paths, it will search that whole share, as much as you have access to, based on your permissions. So yeah, it's anywhere that is accessible from your computer. Could take a long time. Especially if it's a really big file share. Any other questions about find?
It's going to be more awesome than anything.
Have I convinced anyone that maybe learning the shell is a useful thing? Yes. Okay, I got one. 2. Yes. Okay. Aw, you guys. Okay. What else did I throw in here? Find takes this type argument. So you can, that type D is anything that's a directory, and -UID is who owns it. So this would give me directories owned by root. Root in Unix world is the super user account, which can do pretty much anything. Somewhere I saw a T-shirt. I can always tell Unix nerds T-shirts because it's probably something like this. All right. The Mac likes to put file shares under volumes. If you plug in a portable hard drive, it's probably going to put it under volumes. So this would be all the directories under volumes, and -def says don't go too far. So if it's a big share, I don't want to see all the directories, but that would kind of show you what's been mounted on the machine. So this one I had a, that's funny. I had the file I couldn't see. Oh, that's why I did that. So I run this command, I plug in a portable hard drive, and there's stuff on there that I don't have permission to access, and I start getting all these permission denied errors. I'm like, that's no fun. But it turns out I happen to have what's called Sudo Access. And if you can, the Mac actually does ship with Sudo, so you can actually do this on your Mac, which will allow you to run things as root, which is the super user, and then the command will work. If you're curious more about that kind of stuff, there's a lot of work that goes into how do you map user accounts across different platforms. So if root's the super user on Mac and Linux, and if administrator is the super user on Windows, and I create a file on a file share that both look at who gets to be administrator and what does root do versus administrator. And there's a lot of work that'll go on sort of in the IT side of the house and figuring these kinds of things out. Large files, so I just filled up my hard drive and I want to find all the large files. And now I put sudo in front because I want to make sure I look everywhere. Here I'm looking through all of the users folders for everything larger that's 1,000, larger than 1,000 K. Kind of useful if you're filling up your hard drive, you want to find all the big files really fast. I was working with one guy and he had a script called Big Files. I says, oh, that's pretty cool, what does that do? So it tells me where all the big files are. Oh, that's really useful. And so I took a look at the script, it was just this one line. I mean, great, but like it's not that hard to learn. Okay. This shows you all the big files modified in the last 2 days, so if you keep filling up over and over and you want to see, then you find out like your buddy's putting stuff there, right? Just to mess with you. All right. How much do I want to go into this? Find actually has a lot of power, and it'll actually run commands. So you could actually have find go find all the files bigger than a certain size and then remove them for you automatically. This would be very bad if you're storing your homework and your important pictures and they're bigger than that size. You know, my video project. But it can. So this shows sort of the power in find of executing commands, running commands. So find ~type d -exec du -sk. That will search through your home directory, give you all the directories, and then do a du on each of the directories, which will tell you disk usage of each of them. So that'll tell you how much disk space I'm using in every folder in my home directory. Could be useful if you like knowing that kind of stuff. Especially useful if you happen to be a system administrator who generally helps people find out why they filled up their home directory. The next thing we'll find exec. Find -m time +100 -exec. Okay, so that's going to go through and find everything that is older than 100 days and remove it. Don't think that's like really rude, right? If you do that to somebody else. Your file was older than 100 days, it doesn't matter anymore. Yeah, that's why I put don't run this one. I think I set up the example code that's on GitHub so you could just run it. And you probably, I think this one is commented out in the, I hope it is in the script in case someone goes through and just starts running them. DS store is this thing that gets created when you're copying between platforms, the Mac and Linux a lot. It's the way that the Mac carries over its extended file attributes to Unix land. And usually if you're, you want to clean those up, so. It's amazing how many people just like that last line looks like pure magic to them because they have these DS store files all over the place. If you've never been a Mac admin or gone between the platforms, you're like, yeah, don't care. All right, grep, the all-over most useful Unix command perhaps. Grep is a pattern matcher. It matches patterns. And grep is really useful for searching out for patterns in different scenarios. For example, if you wanted to look for the pattern root, which is a super user account in the password file on a Unix machine, you could grep root out and find it. You know what, let's see how they set up this container here. I know. Okay, it's here, right? Now, where's that, all the way at the bottom? This Chrome? Oh, good. Okay. Grep root etc passwd. Oh, well, it would help if I typed it right. Oh, there you go. There's root in the password file. So etc password is a text file, and that's the local accounts on this machine. You don't get to see their password. That's what would be where this X is. So no, you can't hack someone's account this way. Sorry. But this shows you, it goes into that text file, it looks for this pattern, and it prints out the line that has that pattern. So if you had some big text file and you're like, you know, I was sending an email to my Aunt Marge and I saved it out somewhere, but I have 100 text files and I don't remember which one's the thing to Aunt Marge. You could say grep star, which would be everything for Marge, and it would show you which files have Marge in them. So you can search across large numbers of text or open and search many text files very quickly with grep. Is the shell really starting to sound a little useful? Yeah. I can do stuff with this, right?
Yes.
Okay. Then I go back here, that. Okay. But this is my Mac. That's what I was doing wrong. one had 2 hits. Okay. You can't remember if you typed Marge with an uppercase M or a lowercase m. So you try uppercase M and it doesn't find anything. Okay, well, yeah, I guess I can't spell, so I use lower cases only. grep-i is case insensitive, and it'll search through things and find you patterns not sensitive to case. This probably doesn't mean a lot to you if you're not a Mac admin, but the Mac stores a lot of configuration of these things called p-lists, which under the hood are XML files. You know, like, I don't know what an XML, and I don't want to know an XML file. Well, if you did want to know what an XML file, they kind of look like this, and a lot of Mac p-lists are XML. So you could go through and figure out configuration of stuff, like, I want to know what version of something is installed, or something like that. You can grep through multiple things at once. Like, remember the star? Remember I talked about wildcards, and they're super cool? Here I'm searching through all the p-lists for multiple applications on my Mac. Remember regular expressions, and everyone's head hurt just a little when I talked about them? This is a more complex regular expression. So this is searching for a version string. It's a number dot number dot number is what that's going to search for. 0 through 9, so any number. Plus means more than one of them. Within a bracket, it's going to match. Then a dot, multiple 0 through 9s, dot, multiple 0 through 9s. This would search for version strings in a bunch of p-lists. So you're like, I've got a whole bunch of text files and there's a number in there, and I want to go through all of them and look for the specific number pattern. Regular expressions and grep to the rescue. Someday you're going to be stranded on a desert island, and you're going to be like, I got to search through a bunch of text files. And you're going to be like, grep and regular expressions are going to save your life. Hopefully you have a soccer ball with you too. All right. Find all the directories in my home directory and look for Mozilla. I was probably looking for, like, I don't know, app caches or something. Also useful if you're hacking someone's account. ls/applications, grep-i, grep Safari. So you can actually run commands in the shell and then send them over to grep. So remember when I was doing those listings and was showing all that stuff, and you're like, I want to take all that stuff and condense it down to certain patterns I want to look for. The Unix shell supports something called a pipe. So that little line there, what's its thing? It's like above the slash, the key above the return key. There's a slash, and above it there's that pipe, that line. You're like, I have never used that key, right? You're like, what would anyone ever use that for? It's super useful if you're a Unix person. That's the pipe command. And that'll take one command and pipe it into another. Key suddenly became useful. You had it on your computer all this time, didn't know what to do with it. Top. Top will tell you what's running on a machine. So you can go to a Mac right now, open terminal, type top, and you can see what's running and what's consuming the processor, what's consuming the memory. Machine's running slow, you can look at the load and see what's going on. There's a typical top output. That load average number, generally, in fact, at the very top, this one was a 2.45. If that gets more than the number of processors, then your machine, you're probably noticing it. So if you're like a 2-core machine, if you have a 4-core machine and that number's 17, you're like, yeah, that's why, something's going on. All right, move is for moving one file to another place. I won't go into that too much. But here's an example where you can create, touch is just a, the original Unix guys in the 60s had a lot of weird commands, like touch and finger, and I don't know. I think they were bored. But touch will create a file. And then you can do an ls, you know, here it shows example of the file. Now this operating system was like, I think 1969 was the birth of Unix. So it's been around a really, really long time. It's kind of cool working with technology that's like older than you. All right, rsync. This is a way on the command line to copy stuff. So I've got this flash drive I've put into my computer, and I go into Finder and I browse to it, and I take a folder, and then I drag it over to my Mac desktop, and then it does that preparing to copy thing, and you wait for a while while it says preparing to copy, and then it starts copying the files, and you see a little progress bar move. You can do that whole thing from the shell. You can open up a shell, you can do rsync-av/volumes, my flash drive name, to ~/desktop, and copy the whole thing and watch it run in the shell if you want to. So here's just examples of rsync. Tilde downloads, remember tilde is my home folder, so that's the downloads folders within it. I copy it, in this case, to a temp folder. $home is my home folder. All right. Here's the commands we talked about. Do any of them look familiar? Do you remember any of them? Or is it all like just a wash in your brain? Yes. Okay, we got 2. That's so awesome. Chmod change. Okay. Open was the whole thing. I can open a thing on my Mac, so I can like open /applications and /run an app. Disk-util is if I need to do disk partitions, which you'll probably never do unless you're a Mac admin. ls is listing, see what's in a folder. Chmod was the change permissions on something. Chown is change the ownerships of something. Du is disk usage. Df is disk free. Find is search through my hard drive and look for things. Grep is that pattern matching thing. Super useful. Most useful Unix command ever, perhaps. Top is how much is what's running on my machine. Move is to move things, and rsync is to move files around. One of these is going to stick. You're going to be like stranded somewhere. I'm saying you're going to be like grep is going to save your life someday. I also snuck in a bunch of other stuff, like the tilde for your home directory, the pipe command, and some of these I just glanced over because you're not all Mac admins, so some of you probably aren't fully interested in all of these. Sudo to run things as root. Remember, root is the most powerful user in the world on Unix. And we talked about binary a little bit and file permissions. If this stuff's interesting to you, you can just keep learning this stuff, well, forever. There's like lots of commands, and they all are changing and evolving. And here's just like touching a few of them. All right, that's the end of the technical stuff. Okay, does anyone have any questions? Doesn't have to be about technical stuff. Somebody has some question. All right.
And the company of Disney, how easy is it to move around different positions? I know you said that IT encompasses a whole variety of...
Excellent question. So he's asking at Disney how easy it is to move around. Disney is a gigantic company. So when people hear Disney, they always, obviously you think about Disneyland, right? And you think about the Disney cruise lines, and then you might think about Imagineering, where they do stuff for the parks. You might think about Disney Animation, which is where I am. We do, the feature films. But then you could also think about Pixar, right? Because Disney owns Pixar. You might think about Marvel, because Disney owns Marvel. You might think about Star Wars and Lucasfilm, because Disney has that too. You might think about ABC Television, because that's Disney. You might think about ESPN, because that's Disney too. So Disney's actually like super gigantic. There's really no limitations to the number of people you can meet. We have a corporate-wide corporate directory, so you can go in and find other people that do what you do and get to meet them, and I do this a lot. So really it's just limited to opportunities that come up and how they match a person's skills. Disney does have a career site, Disney Careers, I think it's called, DisneyCareers.com. And even I'll look, because I'll be curious, what are the other divisions doing? I've got this new project I'm spinning up, hey, Kubernetes is kind of cool. I wonder who else is doing this kind of stuff. Well, let's go to Disney Careers and see what kind of positions are out there. Maybe there's some other hiring manager I can talk to, and we can talk about our projects and share ideas. So yeah, it's definitely something that people do. But not just for different jobs, but also just kind of in general to share best practices and ideas. Someone else must have another Disney question. There's always Disney questions.
Have you worked with Island at all?
A little bit. Yeah, they're also, in the creative content. I've been up to their studio. It's pretty cool. The one with Presidio. They have a pretty cool campus up there. And you can actually, I think you can drive right up to it and go in the lobby. I don't think there's any gate around the main area. You have to have an escort to like get into the building, but I think you can like go up to the Yoda fountain, just in the Presidium there. It's pretty cool. It's a nice place. All right. Yes, sir.
So would you say that Mac OS is the most predominant operating system in Disney right now?
It depends on where you are at Disney. So our filmmaking process is predominantly on Linux. We are Linux on the desktop for most of our digital asset production. We use Mac in story and editorial and a few other places. Disney as a company, it really depends where you are. There's parts of the company that are predominantly Windows. It really depends on the division and kind of what they're trying to accomplish. Where I am is I'm mostly in the Linux part of the world, personally, but I also support Macs. So I manage what's called an infrastructure services team. So I actually manage the Mac administrators, the Linux administrators. We do have someone doing a little bit of Windows because finance uses Windows. That seems to be universal. No matter where you go, the finance department uses Windows. We also have a lot of administration of like third-party services running on servers and things like that. So it's pretty diverse. What else? That's it? More questions? All right, you guys. Well, thank you. Thanks for spending Saturday morning with me. Especially if you stayed awake the whole time. Extra bonus. Yes.
I'm just starting soon.
good. So while we have the people that's in the room right now, how many of you guys are familiar with Docker? Looks like nobody in the room is familiar with Docker.
Heard of it.
Right? Huh?
Same,
Heard of it. So obviously you won't know Kubernetes from that standpoint.
I've heard of it.
All right. Have you guys ever heard of containers?
Yes.
Okay, so Docker is a one of the containers that is most popular. The second most popular is Rocket. Do you guys know what containers do? Huh?
Mini OS, not exactly full-blown OS,
Okay, you're scratching towards the right area. Moving towards the right direction. Anybody else? Okay, so, all right. What year are you guys? Second years in the room? Second year? Third years? Third years, fourth years?
Fourth years.
So we got some fourth years. I used to teach 466 way back when, about 10 years ago. So this would be much more closer to a 466 class, a 466 lab, if you've ever done it.
What does that translate to? We're not from school, so.
Oh, what school are you from?
We're from Cal State Northridge.
Cal State Northridge. Last year they sent a whole bunch of people from Cal State Northridge also. So 466 in Cal Poly terms is the senior project class. Yeah, it's been a long time. It's good seeing you. We'll talk about a little later.
Yeah, if you step in the speaker room.
Oh, all right, awesome. Yeah, so the way that classes are arranged at Cal Poly is that there's 100, 200, 300, 400 series, right? So it kind of equates to what year you're in. There are different tracks at Cal Poly. There is the app dev, the system admins. There's a security track. Big data is also a little big one, right? Mostly this conference is sponsored by is the security folks, right? So that's Professor Pike is the person in charge of that department. Anybody from Cal Poly, feel free to. I didn't go to school here, so you guys are feel free to fix what I say, right? Okay, so sort of 5 after, and I've got a whole bunch of material. We can move as fast or as slow as you want. So we'll just start. So let me introduce myself, and then I'll talk about the topic, and then see if you think you're still in the right place, right? This is my 4th year coming to this conference, I think, or 3rd year. I usually talk also at Scale. You guys are familiar with Scale? Some of you guys are, right? For app dev, there really is no equivalent. There is a security OWASP, if you've ever gone to that conference. It's in Santa Monica this year. And for development, it's a little bit more like the hackathons that you'll typically go through. If you've ever gone to the Facebook hackathon or the Google hackathon or whatever, they're usually sponsored either at UC Irvine, UCLA, UCSD, whatnot, right? My background is I graduated from UC Irvine back in the 90s, dating myself, and I've worked almost 14 years of my life. I've worked at IBM, and my specialization there was e-commerce and portals, web application development. So some of the things you might have seen my work in: Forever21.com, Costco.com, Sears.com. The largest websites, probably some of the largest in the world, millions of transactions per hour, millions of orders per hour, and our big goal is behavioral manipulation. So how can we get you to spend that next $3, $4 for you to get free checkout? How can we make you go and spend $50 more, right? How do we do things like wisdom of crowds? You guys heard of wisdoms of crowds? Mm-hmm. Right, so yeah. That's, okay, so here's another story. because I work both parts of retail, not just e-commerce, but in stores. Why is it that the most common things that you buy, like milk and eggs, are in the back of the store?
So you have to walk through and see all the other stuff?
You have to see watch all the other store. What is the most profitable items that is sold in a retail store? Where is it located? Alcohol is a good, it's a good guess.
Cigarettes?
Cigarettes is a good guess. So it's actually the products that are at the checkout line. Because you're waiting there. Do you really think that candy bar is $1.25? No. They're making a whole freaking load of money on it, right? So I did retail for a long time, whatnot, right? And then now I'm over at Red Hat because Red Hat is all about open source, right? So I'm Red Hat certified system administrator. I'm a certified application developer on the Red Hat platform, blah, 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 blah. We are a 9,000 person company, $3 billion company that basically does free software. All the software is for free, right? What we charge for is not the software, but in the services. So whenever you need to get support, you need to ask for questions, you need to ask for help, you come to Red Hat for those answers, right? So it's very much like the razor blades and razor theory. You guys know what that is? Give the razor away, razor away for free, but you make money on the razor blades, right? That's the thing. Software is for free. Once you use it, you'll find out there are limitations, there are problems. You can't do certain things, whatnot. Well, if you want that to work and want that to make that happen, then you go and hire Red Hat. That's for all open source software. It's not just for Red Hat's pieces of software. That's also for anything with an open source license. You'll typically see there's two types of licenses. There is a community version, which is technically free, and then there is a paid enterprise version, which actually has a lot more stuff in it and or has gone through a different type of hardening. Case in point, if you look at the community version of our operating system, it's Fedora. Fedora has 9,000 some packages, plus more, depending on where you go and talk about. RHEL only has 4,000. Because why? We go through a 6-month QA process with RHEL, because we have to support it for 10 years. Guess how much software doesn't pass the QA process?
80%.
A large portion of it. Because why? The community doesn't have is a $500,000 storage rate. Right? They don't have specialization skills to install Oracle database. They don't have skills to install or do performance tuning on SAP software like SAP R3. Right? You really think a bunch of guys that are working on open source software on their laptop in a co-working place or at Starbucks is really going to have $1 million worth of software on their laptop and go and doing that type of work? So this is the value that you get. Please come on in. The value that you get by getting the enterprise versions of all the software. It's gone through a much more stringent QA, hardening, security, all that type of stuff. Our Fedora versions do not get that security, blah, 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 blah. All right. Okay, so now you know the differences between community and enterprise. Great. Now, what is today's lecture about? So today, this is an 8-hour class. It's, I'm only teaching the first 2 hours of it, right? So why is this, why are we talking about containers and Kubernetes and whatnot? If you guys, okay, so the 4th year guys are a little bit more closer to it. They're trying to apply for jobs right now. And if you're gonna look for jobs out in the marketplace, I can tell you there are certain things that you're gonna be looking at, right? They're gonna look at programming languages. They're going to look at configuration management tool like Chef, Puppet, Ansible, or SaltStack. Ansible's owned by Red Hat, right? Then they're going to also look at things like whether you know containers or not, right? And if you're on the back end, maybe database, NoSQL, or big data type solution from that standpoint, right? Now, why is containers so important, right? Well, I'll tell you the largest one in the world. The largest customer, or not customer, user of containers in the world is Google. They have about 1 billion containers in production today. and they provision and deprovision several million every single day, if not every single hour, right? So what is a container? You can think of it as a way for you to go and provision software on a system, right? Think about, have you ever tried to get one of your friends, like you have a group project, right? Have you ever tried to get one of your friends' machine and says, here, just set this up on your own computer, it'll just work? And they'll read the instructions and try to do it, and they'll get into some type of problem, right? We call that problem, try duplicating environments, we call that configuration drift, right? So that's where dev 1 doesn't quite look like dev 2, doesn't quite look like dev 3, dev 4, whatnot, and then you get this problem of like, why can't this one thing work? Well, because each environment is different. Maybe non-production doesn't have HA, right? Maybe non-production doesn't have is a clustered environment. So what happens, a lot of companies and other people is like, well, the only place we have HA and clustering is in staging, right? And guess what? You see all these new problems crop up, right? And if you remember, for some of the people about software engineering, you guys probably read Mythical Man Month and all that other type stuff, right? You guys know is that it's much, much more expensive for you to fix problems that are much more later in the environments than when you fix it in the first environment you're in, right? Either a lab or dev 1, right? So everybody went to this, so everybody's had different ways of figuring this out now, right? So some people in the Linux world says we'll develop an RPM. Other people in the Windows world says we'll do a setup.exe and then we'll package all the software, whatnot, right? But if you've ever done any of that, there's still more manual configurations after the fact, right? You still have to localize. You make sure that dev 1's web servers point to dev 1's databases, dev 1's usernames and passwords, dev 1's specific configurations. And then dev 2, dev 3, dev 4, you have to do this over and over, right? And this is why there are so many admins, right? If you ever see what they're trying to go do is that they're trying to get consistencies among the environments, and it takes time for you to go boot that on up, right? In the worst case scenario, so you've got some of these older companies that they have to have things like a downtime. Schedule like 2 hours out of the day or a weekend for them to go and do updates, because this is the only way that they can shut down all environments, clean out everything in the queues, remove all transactions, and then they can start doing upgrades along the way, right? And provision the new pieces of software, make sure that this boot up sequences are all correct and all that other type of stuff, right? Years ago, Google said that this is stupid. It's actually horrid. Why are we even doing this type of software world? Why do we have to boot software in sequence? Why do we have to go and do all these different things? Isn't there a better way for us to go do it? So that led to the invention of containers, right? And at the very end of the day, a container is, and I'll go to this. These slides may be a little bit more, I was expecting a little bit more knowledge on the product. But think of a container as a binary blob that has OS libraries, runtime, application, and application settings in this one binary, right? This one binary is the same all the time, right? It's all just one piece, right? So when you give it to Bob, Joe, Albert, George, right? It's the same binary that's being installed all the time. In Dev 1, Dev 2, Dev 3, Dev 4, staging and production is all the same, right? There is no differences between it. In fact, if you do an MD5 hash sum of it, it's the same hash every single time, right? So now we've gotten to the point, and they call this immutable infrastructure. So think about it in terms of security risk. If anybody breaks into the environment, the hash will change automatically, then you know you have a compromised system, right? When someone else says there's man-in-the-middle attacks, someone else has intruded into your development process or your DevOps environment or into your build systems, the hashes will always change, right? So you'll always have this way for you to figure on out if it's been touched. Anyways, moving a little bit forward is that if we can get this one binary to run exactly the same all the time, then we get commonality across all the environments, right? It sounds easy. It sounds easy, but for 40 some years, computer science has not been able to crack this nut. It's been this long for us to kind of figure this on out. Docker was took a bunch of technologies, Docker containers, took a bunch of technologies and made it much, much more easier for the normal consumer to go and for the normal IT person to go and deploy and put that out into the environment. All right, so I just want you to get the idea here is that when you go apply for a job, they're going to ask about containers. Just tell them that it's a way for you to deploy is a piece of code out in the environment. That's it. That's all I want you to go figure it out. You can read up later about a lot of the whys. I want you to go to the labs because that will give you hands-on to sort of says, this is why you can kind of feel, if you've ever tried to go and set up someone's environment, like your teammate's environment or somebody else's like trying to get code working on their environment, they're like going, why can't this just easily work? You can go and compare and contrast. You guys are smart, we'll figure it on out. Now, there is another problem with containers. So containers by itself is only the binary, which is the code for that piece. Now, that piece, if you've ever seen in Docker itself, has no logic. It has no understanding of itself, right? Meaning that it's just code that runs on it's a process that runs on a system, on an OS. So you're gonna need something that's smart, something that is able to go tell it when to provision itself, when to deprovision itself, what usernames and passwords to use, all this other logic. And that is Kubernetes. That is what we call as an orchestration engine. Kubernetes was originally written by Google, and it is used in Google Cloud. That is how they manage containers at scale, right? So think about it from one aspect, right? You've got a bunch of processes running on the machines, right? One process does not know another process exists, right? They're just running. Then you've got to have, just like in a band, you've got to have a person that everybody's doing their own thing. You've got to have, as a bandmaster, someone who's orchestrating everything, right? That is what Kubernetes is. It tells it to provision, deprovision. It tells it that this environment is supposed to be its own VLAN. This environment has these type of security credentials, all those type of things, right? Just know that it has orchestration. I'm going to go skip through a lot of different things because we don't have really that much time, and I'll explain from everything. If this is also, you guys, this is your time, because yet again, this is typically an 8-hour class, so I am really whizzing by to get you to the hands-on pieces. Ask questions, because there is no dumb questions in this place. You guys are trying to go and learn, right? As a second year, when I was in school, I didn't know anything about IT. I didn't know, I was really good at fixing computers, really good at playing video games and getting my video card driver to work and getting the frameworks I wanted, right? Right? That's what I was good at, right? Programming was a whole different thing. Joining out in the industry and understanding how they build software and why they build software, that was a whole different thing, right? I wanted to ask another question of the room. So, in the beginning I asked how many of you guys knew Docker, Kubernetes. You guys didn't say anything from that side. How many of you guys have installed your own Linux server before? Okay, so 2/3 of the room has installed their own Linux server, right? All right, so I at least know for that. What do you typically deploy on that server? Do you guys have a LAMP stack, a mean stack on it? Okay, I'm getting some nods from that standpoint. Typical web server.
I use it for app dev.
For app dev, right? Your own Quake 3 server. I don't know, Team Fortress? Anybody else? No? Yes? Huh?
Game server.
Game server, right? You guys now have Discord. You don't need to have your own TeamSpeak server anymore, right? All right, so I'm going to break down how, maybe this into Google terms, about how the way Google runs their infrastructure, all right? So that you can kind of get an understanding of, like, logically, when you go over to Gmail or a Google search, how it really runs, right? There are actually two operating systems inside of Google. There are what are called, it's analogous to, it's not exactly the same because I'm doing some rough translations, but there are master servers and there are nodes in the network, right? So you can think of the master as the orchestrator, right? That's the one that runs everything from that standpoint, right? And then these nodes are basically very much of minions, right? They just basically run workloads, whatever you have, right? Does anybody know that there's actually two variants of OSs that are running? No. So the master, which in this case, I'll put it as RHEL, right? Red Hat Enterprise Linux. A typical install is 8 gigabytes, right? 4,000 packages I mentioned, right? You go and configure that, and it's basically a typical OS, right? But when you're at Google and you have millions and millions of servers, that 8 gigabyte install, is it efficient for you to install that same 8 gigabyte across all million servers?
No.
No, because you're not going to run all those things. In fact, your surface attack area is 4,000 packages that need to be patched all the time, right? So they have a second type of OS. In this case, we're talking about Atomic. And Atomic is just enough OS to run a container, right? It has no telnet. It has no SSH, right? It doesn't even have, like, if you log on in, it doesn't have a user. It doesn't have a var directory. It doesn't have any of those things, right? It's just enough to run is a container. When you think about that, why is it the case? Now you've slimmed an OS install to something to a couple hundred megabytes, just enough for the kernel to go and run. Typically, if you've ever joined as a company, when you join full time, the first thing they'll say is security, security, security. And what do you do by security? You basically deinstall everything you can off of the machine, right? Right?
Yeah.
And in the Linux world, we would have a kickstart script that basically with the minimum, anything that isn't needed is a potential security hole, and it will go and take MIPS from your machine. And in Google, every MIP that you don't optimize times 1,000,000. Think about the power costs. Think about how much money they have to pay for that unoptimization, right? So you have basically this OS that's like basically not even just, think about it in terms of, does it even need a hard drive? Maybe it runs purely in memory. Boot TP, boots it off the network, and there it is. It's just pure raw computing power with just a little OS on it, right? That's what Atomic Host is. Really interesting, right? In fact, even if you patch the machine, you don't actually even patch it. There's two partitions. One is active and the other is passive. So when you do updates, you do it to passive, and you reboot the machine and it flips to the other partition, and that becomes active. And if it fails, then it boots back to the other partition as failover, right? Anyways, very, very cool, right? Much more different than a typical RHEL machine. Because RHEL machine, we have in this cloud native world, we talk about it in terms of pets and cattle. Have you ever heard of that terminology? No. Okay. In the cloud world, okay, in the old world, we call it pets. And the reason why we call it pets is that a server like that, we give it a name. It's got, like, at UC Irvine, we named all our servers after alcohol. So there would be like, Budweiser, Heineken, whatever it is. That was our servers that we logged on in, right? So we gave them names, and guess what happens? When it crashes, right, we got to go and heal this sucker on up, right? So what would you do with these servers? We put HA on the environment, we put monitoring software, it's got daily backups, it's got all this stuff, it's like bulletproof, right? It's got everything that we throw at it, right? Because why? Like if it's sick, we gotta heal this machine back up, right? Well, in the new world, in the cattle world, what happens when a server is sick? We take this, it's the same thing what happens with cattle. When a cattle is sick out in the farm, I'm not sure if you've ever seen it, they take it to the back of the barn, they shoot it, and then they get another cattle and put it back out on the field. So in this world of Google, do you think they actually do fixing of any of the machines? No. They kill the machine, kill the container, right? And the workload dynamically moves to other members of the environment. There's other systems in place to make sure that if the requirement was that there's 10 instances, it will provision from 9 back up to 10, right? It will do all these things, right? Because all the servers are exactly the same. What is unique about it? It has no resident data. It has no state in any of those 10 machines. State exists in the master. These are just raw data and raw compute power that I need to bring to bear to run Gmail whenever I need to feel like it, right? So, different way for you to think about things, right? So, you've got OSs, and then you've got the application that will come from Docker. You'll play around with this later. Just trust me, the application will come down, right? So this is where there's a Docker container for most of the, as of right now, there are thousands and thousands of what they call Docker images. These are pieces of applications that are out there that you can install on your machine, right? So there is a Docker container for MySQL, there's a Docker container for Apache, there's a Docker container for Apache Spark, you name it across the entire board. There are all these Docker images that you can just go download, right? And we download from a place called Docker Hub, which is a Docker registry. Think of that as kind of like LDAP for application software. Right? Above that, we have to have is a orchestration system. So if you've ever built an environment before, you're going to have several problems, right? So when you have not just software running, you have to also think about, I have to have network. I have to have storage. I also have to have a way for me to do logging, right? Because in the old world, think about it, it makes sense for the for storage and networking, right? So what happens is networking-wise, there is if you've ever seen some of the software-defined networks, we provide one, right? You guys know what I mean by software-defined network, right? It's basically a software-based router, right? Layer 7 or layer 3, you name it across the board. There's different companies that do it. So there's network. Storage. Storage, you guys know that there's 3 major types. You guys know that? 3 major types? Okay, I see some people down in the room, don't know. So there's file, block, and object, right? You guys can look it up later. There isn't a test for this, right? So, like these. Just know that there are 3 types of storage, and there are different use cases for every single one, right? So you need storage, depending on what it is, right? You need a way for you to be able to find software. Well, that's what the registry is. Logs. So logs is really interesting, right? You guys have typically only managed maybe 1 server, 2 servers, 3 servers, 5 servers, right? Small amount, right? Think about if there's a problem in the Google infrastructure and there's 1 million of these. Are you going to log in shell into every single one of those 1 million instances to see which one is the problem? No. So what they do is they do log aggregation. They basically stream the logs out of all these machines into a central data warehouse, and then that's where they get alerted on, right? In fact, they say things like 70% of Google, 30% of Google's infrastructure is typically down, either for scheduled maintenance, uninterrupted failures, whatnot, and you don't see that because they're in the cloud world, right? Where I'm talking about this pets versus cattle type of idea, right? in the pets world, if you ever told, like, you guys are building a data center, I think, across the street, right? And if you just said, guys, we're just going to shut down, like, this server, like the LDAP server, the authentication server for, like, a day, you get, like, hell, everybody's, like, breaking out. I can't log into anything. Single sign-on's down, blah, 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 blah. In the Google world, when have you ever seen an outage? Have you ever really seen an outage? Right? That's not their fault, right? Typically, it's like a level 3 or one of the big providers, right? They have like something that's really messing up, right? But not necessarily Google, right? Because they've inherently designed that everything in their system is a cow. And so they can move workloads and have redundancy across the entire environment, right? So logs, a way for aggregation. Monitoring is a really big deal, right? Because the thing is that no one cares if your process no one cares about whether the OS is up and running. Really what they care about is whether or not the service, either the website or the REST interface or whatever it is actually providing the data that they want, right? So you always have to think about it in terms of endpoint and security, right? So what Kubernetes does is Kubernetes brings that all together and formulates and builds the data center on the fly every single time for somebody, right? Because the thing of it is that in the new world here, right, when resources are dynamic, right, used to be like, why do we have like dev 1, dev 2, dev 3, right? It's because the thing is that we don't have enough IT resources. In the real world, how the way we would ideally want it is every developer has their own sandbox. Why should we be forced to have a shared sandbox with everybody else, right? Think about it. Someone's using dev 1, and then the guy tells you, no, you can't use dev 1 because another team's using it. And then another team says, like, I need to go use dev 2, dev 1, dev 2, and they're like saying, well, this is different in dev 2 to dev 1, you have to go back to dev 1, you have to test this, the single sign-on's only enabled on dev 3, all this type of funkiness that's have in this environment, right? But in the new world, that's not what we think, right? Think about it if some of you guys have used like AWS. You just go out there and you go says, I need 10 servers, it provisions out 10 servers, hopefully you have some scripts that will configure everything, and then you're like, I go and use it, right? And then when I'm done with it in an hour, I just throw it away. It's gone. It's what we call ephemeral, right? It only lasts for a short amount of time, right? This is the way that we're developing code nowadays. So what's the concept? What's the value of naming it dev 1, dev 2, dev 3? It actually doesn't mean anything anymore, right? What you really what the real need here is, I need an environment that is very similar to production. Give me that. Let me deploy my code, test it on it, and when I'm done, it's gone, right? Don't give me is an environment that is partially looks like production, and then I find out that when my code gets pushed to production, it doesn't really necessarily work because it's missing a couple features, right? Think about that, right? Think about like what the real thing that people are really looking for, right? And then you're going to have on top of it is DevOps. Most of other people, I'm not sure how much DevOps you guys have taken, right? Some, seems like it. Most popular one out there is Jenkins. CI/CD, there's a third C now, it's called CS, continuous security, right? So think about the thing as like, so CI deploys all your code, right? So you have databases that are deployed, messaging engines, web servers, right? NoSQL systems, all of it deployed. So you may have 20-some servers, 6 different groups of this 6 types of applications on these 20 servers. CI provisions this all out and glues all the networks for it. So maybe the database and the web server is in one VLAN, but the NoSQL servers cannot see the SQL servers, right? They're all in their own separate VLANs, all the networks being configured that it's done like the right way, blah, 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 right? think about that also in terms of, so all the integration and connectivity, all the keys have been sent to each other. Everybody has, everybody's not shared keys. All usernames and passwords are generated dynamically, all this great stuff, right? Continuous deployment is just going to sort of say, hey, I will have automated test scripts on my code base. So if I run this automated test scripts, and if they pass, it will automatically promote the build to the next person or the next environment. Typically, what happens is, if you ever heard of chat ops, it will go and message like the QA team, build 53 is ready for testing. Build 57 is ready for testing. Build 60 is ready for testing, right? So then the next guys will go and follow up behind that environment and then go do that, right? Some of the CD is automated and some of it is manual. The most famous one out there was, do you guys ever heard about the story of DevOps, how it got birthed? Okay. 2009, a bunch of engineers showed up to the Velocity conference in San Francisco and said something shocking. They said that these are a bunch of system admins showed on up. And it says, what is everybody doing? One of the engineers stepped up to the podium and says, we do 20 plus deployments in production a day. And people were like, what the? Right? We can't even get one. Typically we have one person who, is a build master. Everybody sends all their code and then builds this master thing, and then we spend Thursday night testing the crap out of it, and then features drop, some features get patched, and then we push it up on Friday morning so that we test and see everything is working on Friday, right, in production, right? They're like going, and we can only do this once a week. And if you've ever had an internship, some companies only can do this once every month to go into production, right? They're not even on this whole weekly thing. They're like, if we get weekly, we'd be magical, right? And you're telling me we do 20 plus production deployments a day? So this company, the name of it was Flickr. And they said, we've got an idea. If we can make a change unit just to be one item, we can accelerate the velocity of changes. So what happens is one change, one build into production or in any environment. If we know it fails, we can regress that and then move to another one, right? But if we can automate this in such a fashion that we can go and do one change, one time, and make it sequential, we can move the code base forward very easily and move it back very easily, right? Because of that talk, it launched the concept of DevOps. 2003, Eugene Kim wrote a book called Phoenix Project, which is the most popular IT book off of Amazon.com. If you want to meet Eugene Kim, Red Hat has sponsored him to come to Southern California in a couple months. Talk to me later about it. I can get you probably a pass to go and see him speak. So 2003, the book was written, and then it also launched the conference, which is called DevOps Days. That's the one that most people attend now, right? And because of that reason, there's this whole movement of doing DevOps in general, right? So that's, anyways, so this idea of like CD was very, very new. So CD, you'll hear about it in different companies, and they'll try to automate that. Some companies can do it, change requests within 15 minutes, all the way from QA testing, all the way to full production in 15 minutes. They push it out. The third C is CS, which is continuous security, and what they're trying to go do is now integrate into the pipeline is things like code checking. So if you've ever heard of OpenSCAP, you've heard of some of the other security tools. It'll do static and dynamic testing of the environment. It may also do performance testing from that standpoint. There's also other things like Chaos Monkey. You guys heard of Chaos Monkey? Okay, we got somebody. Okay, good. We got some people. Thank God. Everyone asked about this. Okay, Chaos Monkey is a project. It's an open source project from Netflix. And the idea for Chaos Monkey was, what if you let a monkey into your data center? Yeah. What would it have? What would it do? It would go and try to disable and break as many things as possible. So the script purposely damages the Netflix environment. tries to log in, tries to crash every single port, tries to flood every single port, kill every process, change every username and password, right? It's trying to systematically even destroy multiple data centers off of. What happens if I take EC2, US West region, out of the picture, right? What would happen in terms of Netflix's user? And will you still stream movies? Will the provisioning system, will the orchestration system be smart enough to provision enough servers and capacity to actually go and fix if one of the major data centers were down? That's Chaos Monkey. So they integrate this into your CI/CD pipeline, and it's awesome. Awesome when you see it running, right? You'll see that the provisioning system try to go and fix the environment as fast as the monkey breaks it. All right, so anyways, this is kind of like the way, so this is kind of like what I say, like how Google like the data centers. You've got an OS, you've got your application comes through Docker, you've got an orchestration system that goes and manages, is the brains of the data center itself, right? And then you've got CI/CD that developers are pushing code into the environment, right? And then with that CI/CD process, you also have blue-green A/B test. Okay, Canary releases. Okay, so when you're a system admin, you might notice on Google, I'm not sure if you guys see this, but have you ever seen that two people are side by side? This happens actually better on Amazon. If you've ever been side by side with somebody and the web page on one user screen looks different than the other user screen, right? So what they're doing is Canary testing. So what they do is that they deploy the new code into 10% of the infrastructure. So when you're on the load balancer, you might get a 90% chance the old website, 10% chance the new website. And they see if the 10% will actually work or not. And if it works under the parameters that they think it's going to do, that's a canary, right? Because anyways, the story is that miners would dig a tunnel, and they don't know if there's oxygen in the tunnel, and they don't know because they have no oxygen sensors. So what they do is they bring a canary down with them. If the canary dies first, then they're like, oh crap, let's all leave now, right now, right? So this is the same thing in terms of IT, right? We deploy to 10% of the infrastructure. It doesn't look like it's going to break the environment. Okay, then we deploy it on out to all 100, right? We don't do this type of like, it's all or nothing, and then you have this like, website is not available, or Cloudflare says that there's a DOS attack on this, like, site is not available. No. Sites are up all the time. We have to wait for us to think about it, right? So A/B test is where they go and they actually flip a switch between the router, and they just send to one data center to the other data center. The other one is the Canary is where it's more sophistication. So that's what they do at all the major websites. So I mention all this is that all these three things that I mentioned is very analogous to any single place that you go to. So if you go to Riot Games, Tinder, eHarmony, any of the .coms, LinkedIn, Facebook, Google, they all deploy this way. This is the standard operating environment, SOE, for the last couple of years, right? Now, in school, we don't talk about this because we're here to talk about theory, and we're here to go for you to understand like the crawl, walk, run, right? And then we throw you out to the wolves, and you figure on out that things may be a little bit different than school. So this is how it is out in the real world, right? Any questions? So I've burned 45 minutes of your time, right? That's okay. Do you guys want to hear more about the architecture? Yeah. About how it's designed? Yes. Or do you guys want to go straight to the hands-on labs?
No,
Huh?
Architecture.
Yeah. Okay. All right. None of the, okay, to be honest too, we'll talk about architecture. None of this is on the Red Hat System Administrator Certification exam, right? So if you ever want to take that, you guys just got access to it through Professor Pike to take some of the classes, but that's much more low level. I'm not going to talk about it in this, right? But you have to then learn SC Linux. You have to do SC contexts. It's a lot more auto mounting. all that other great stuff. This is much, much more higher up the stack. Right. So let's talk about also a little bit about the typical data center, right? So Red Hat, so before I go into this architecture, this is a opinionated architecture, right? So opinionated means that we've made certain decisions in it, right? So what Red Hat does is that we take open source software and we build a solution out of it, right? Just like what we did for RHEL, right? You think about RHEL is 4,000 some packages that we've kind of combined and we've kind of smoothed in all the hard edges so that this property file won't conflict with this property file, everything will work hopefully in system D, you know, all this kind of, you know, we kind of take it raw open source and then we standardize it to make sure that it's all working with each other and won't conflict with each other, right? So Red Hat, what we did is that we said, okay, if we know Google, Facebook, LinkedIn, all these guys are building this similar type of architecture, right, this cloud native architecture, how can we distill it down to something that's reusable for the majority of the people that are out there, right? So what we did was we said we will take 20 pieces of open source and we'll combine that and we'll build a new product, and that's called Red Hat OpenShift, right? So Red Hat OpenShift is a combination of Docker, Kubernetes. I mentioned about storage, I mentioned about network, I mentioned about CI/CD, all these things, all these products come into that umbrella, right? Now there are two use cases for OpenShift, right? So we have things that we want to do for developers, and we want things that do for ops, right? Because in the new world, right, is that we don't want to go into we want to change the paradigm. So if you've ever worked at a typical company, like how do you get an environment? You send a ticket into help desk, and then like a week or 2 weeks later, you might get an OS provision to you. And then like once you have that, you're like, where's my X? Where's my database? Oh, submit another ticket. We'll get to a couple weeks later, right? And then we're like going, this world? No bueno, no, we don't want this world, right? Well, what we want a world is the developers are like, oh, I know what I want. I just click a bunch of stuff in the self-service menu and it'll provision out this exact environment for me, right? That's the world that we want, right? So that's it. Now, what do the admins do, right? The admins are like going, well, you know, the reason why you put a service desk ticket to us is so that we can make sure that everything is hardened and tested and there's security and all this stuff is already done for you so that we have some type of enforcement of policies to the environment, right? If developers can just go and use their credit card and go on AWS, that's shadow IT. We don't know what the heck happening out there. They could sell all their information and then what happens, the stock price for the company goes down and somebody gets fired, right? So operations from that standpoint said like, well, give us a way. If you're gonna go and provide self-service dashboards, give us a way for us to, instead of us managing individual trees, give us a way for us to manage the forest. Give us a way for us to say, hey, you know what? This MySQL farm is basically running at 90%, taking up all the capacity. I need to kill that, or I need to move this to another node in the environment. Give me the ability for me to be able to do my job without impacting the rest of the developer organization, right? So there's that whole thing, right? So boiling it down, we also have some other things that we need to think about, right, with the environment. We need to be able to go and address multiple places. It's got to be, whatever solution we build has to work on the physical environment, has to work on any virtualization platform, public, private, and it's got to be able to do a mixture of both. Right. So, big thing is, the first thing is that I mentioned a little bit about nodes. This is where the apps will run in, right? And so we have, don't think of that, that's RHEL, it's actually the full name is RHEL Atomic. So that's the stripped down OS, right? And every single little instance, right, is Docker, right? So Docker has an image. The image gets instantiated into a container, right? Think about the image is that this is the template that you can copy from. So there's a MySQL image that's out in the internet somewhere. When it gets instantiated, you have multiple containers. So there's now one image, so image version 5. There are 10 containers of image version 5 that's running, right? Now we also added this other concept of a pod. And what a pod is a group of containers, right? And the reason why is this. Sometimes when you want to scale applications, you want to scale them together, right? So the idea here is that, okay, so this may be a little bit overhead from some of the second and third years, but when you ever build software, okay, so how do you get maximum velocity? This is one of the questions that people ask in the velocity conference. How do you get maximum velocity? And the answer that the person who was at Etsy says, you remove every single dependency out of the environment, right? The less dependencies you have, right, the faster your code actually moves, right? So for instance, if you have 5 applications that are running on one Linux server, what happens when there's a security patch? How many teams have you been impacted? You've impacted 5 teams, right? Right? Why does virtualization work? Virtualization works is because you have 5 images for 5 different teams, so those guys can do whatever they want because it doesn't affect me, right? Now, if you take that analogy and go into the containers world and the developer world, right? You're like going, okay, a VM is great from that standpoint, but what if we can go and sort of say, hey, we not just have so an app is on one single VM and they have multiple applications, whatever it is. A container, we can have multiple instances all over the place and they can all work together, right? So anyways, now you have all these other applications, but they're like asking, but isn't that a little bit of like, VM sprawl, container sprawl, right? So there's a philosophy that we have when we're building containers, is the idea that if you couple, say for instance, a monitoring agent with the web application, right? And these two get built into the same image, guess what happens? When the web server gets updated or the monitoring agent gets updated, you have to rebuild the image. That's bad, right? What you want to have is it sort of says the web application has its own life cycle. Version 1, version 2, every week there's a new version code build. But the monitoring agent maybe only gets updated once a month. But I want to take these both items and group them together. So deploy this as a unit, right? Without the type coupling of them being in the same image itself. So that's the idea of a pod. It'll make sense if you guys will start deploying a lot of code on out there. So pods are what you see on out there. Masters, I said, was a control plane. What it does is that it's in charge of orchestration and scheduling, right? So there is a policy inside of the master, inside of Kubernetes, to say when a Docker container gets actually provisioned, I will not pick the same rack. I will not pick the one that shares the same power supply. I will optimize near the application to near where it is to other places. If you've ever built is a truly distributed environment, you'll know that past 20 miles, basically there's network degradation on the cluster. That's why a lot of the data centers are co-located within 20 miles of each other, the DR. Well, high availability. True DR would be on a bedrock, like on a mountain, which none of Southern California actually fits except up in Sacramento. So most of the DR facilities here in Southern California is actually in Colorado or Sacramento on rock bed. Anyways, so it's in charge of scheduling, orchestration. So it places out the environment. You can kind of see that there is Tomcat here, there's MongoDB, there's MySQL from that standpoint. It's done by policy. It glues the entire environment together. And it also does health and scaling. So what happens is that in Kubernetes, you tell it that this MySQL cluster is supposed to be 10 members. And if it sees that any of the containers are zombied or it loses connectivity, it automatically goes and shuts down and deletes those containers and provisions new ones on out. There's another thing too, is if you've ever done clustered software development, there's health is really important. So there's a difference between whether the process is running and whether the application is a response. Does that make sense? Right? So you start up a server, right? The web server is running, but when you make the REST call, nothing's responding back, right? You don't want to put that service out to the public yet, right? So there's a difference between whether the service is live, right? Whether the process is running and whether the service is live, right? Think about that. So what happens, I talked a little bit about when one of the containers is bad, it blows on up, master does a remediation, automatically moves the workload to another environment. State is not held inside an environment, it's stored out into external storage. Yeah, this is going to be a little bit, you guys haven't gotten to this point yet, but know that when we talked a little bit about dependencies, if you can make it stateless as much as possible and remove state out of the environment, that allows that the software can go and fail and you won't lose any data. That makes sense, right? That's why we have a database. Because we could have stored all the data in the web server. Why don't we? Right? Because if the web server crashes, we lose all our data. So what do? We store it all in the database, so now we can rebuild the web servers and we still can get our data back. Same conceptually, but think about that on a data center-wide idea. The other thing that we did is that you have to have load balancing and routing, right? So the big thing when you join a company is you'll typically have is a software-based router, something like a F5. And what it does is that it sprays across the network to all the application that is running. So if it has 10 instances, right, it will go and say, hey, right, I will go and see new members or members are gone. I will automatically make sure that your request goes to an active machine that can service your request. All right. And then we provide you a way for you to do through web UI, CLI, IDE, whatnot. Does it make sense? Mm-hmm. All right. Any questions?
Can you please kindly, for some people, they may not know what is open source is and what is proprietary software are. So please differentiate between the two. Please.
Okay, so there's a question from the gentleman. It was what's proprietary and what's open source software. So if you go to opensource.org, there is a definition of open source. Right, and it means many things. There's many variants of open source. Typically, what is most important is the license that is associated with the software. So most of Linux is GPL'd, which means that any software that you add to the Linux kernel, right, I'm just talking purely about the kernel itself, that also has, the source code has to be available to other people, right? Now there's also ones like LGPL and Apache software license. Apache software license says that the source code that we provide you is for free. Any add-ons you do on top of it, you do not have to pay for, and you can make a closed source. You do not have to share those at all, right? It's your own choice. Money is typically not part of open source. You can charge for GPL software and not charge for GPL software. There's a way for you, depending on what it is. But your promise is that even if you charge or don't charge, because it's GPL, you have to give the software, the source code, to the other person. Charge for the media. Right, charge for the media. Right. Now, what's not also said about that is whether your services are for free. Your services are not for free, right? Service is different than software. That's why I mentioned that Red Hat, all our software is for free, right? We charge for services. So for our expertise and for our knowledge, right? Because we are primarily, for different pieces of software, we might be the largest contributor of the code or whatever it is. You pay for our knowledge and we'll help you go and solve problems. That's what we go and do, right? Now proprietary from that standpoint typically is all closed sourced, right? That means the thing is that they don't have to share the source code. You get a license to maybe the binaries and then whatnot, right? And the most famous companies from that standpoint are like IBM, Oracle, SAP, whatnot, right? But if you look back at the way they build the software, they actually have parts of open source in them, right? But the software components that they use may be under an Eclipse community license, maybe on Apache software license and whatnot, right? Typically they will avoid GPL, LGPL software because of how viral the license is. Does that answer your question?
Yes, and please tell who are some of your vendors that are Red Hat, like Sprint, I believe, and Boston Medical Center, and
okay. Yeah, that was a little bit more about Red Hat. Let me see if there is a slide about Red Hat, the company. I don't have that. So this was a little bit before you came, but I was mentioning that we're a $3 billion company, 9,000 employees. We are part of S&P 500. We're 20 years old already. Red Hat Linux is already 20 years old, if you can imagine from that standpoint. I believe 100% of the Fortune 500 companies use Red Hat. Red Hat Enterprise Linux is one of 20 products that we have at Red Hat. We have actually 5 major business lines. We have the operating system, which is RHEL, the OS, server OS. We have also RHEL desktop. Our largest client is 80,000 desktops. We have virtualization, which we compete primarily with is VMware. So that's called Red Hat Virtualization, KVM. We have a storage. So whenever you use, all of Facebook.com runs on Red Hat storage. It's called Gluster. That's our community project name. And it also has one of the largest object stores in the world is also Red Hat's too, and that's Ceph. Think of that as kind of like Dropbox, the kind of storage technology. It's you get and set. Think about you push and get files and send files through a URL. We have cloud technologies, which this is OpenShift, OpenStack. We also have a manager of managers that runs on top of that. And we also have the 5th category is middleware. So we have app servers, messaging engines. We used to have a database, right? And that product, gets expanded over and over, right? But nowadays, to be honest, when you talk about Fortune 500 and whatnot, I think Red Hat owns 70% of the Linux market. If you look at the paid Linux market, we have shipped more Red Hat or Linux licenses, subscriptions, than Microsoft OS now. For the past 3 years, we have shipped more Linux licenses, quote unquote, than even Microsoft. And that's primarily driven by is the internet. If you look at the internet, the first OS of choice is a Linux machine. The first OS of choice, if you have your own business, running QuickBooks is Windows, right? So what happens is that there's a domination between those two things. Now Azure and a lot of the new Microsoft technologies are moving into that space, right? We are also moving into their space, right? There's co-competition in both areas, regardless of whatever it is. Now Microsoft says we love Linux, and for the Red Hat people, we use Macs, we use Windows machines. Now it's a much more interesting world, right? Does that?
Yes, I appreciate it, yeah.
Sure.
Thank you.
No problem. So for how many people in the room are they developers? Very few developers? Okay. So I'm going to do this just to round it off. I know this happens to be a system admin track, right? So you guys were interested more about that. For the developers, what we've done is that all this stuff about Docker containers, setting up security, whatnot. I will tell you, as a developer, doing system admin type stuff. Okay, so here's a joke. Don't take too hard on the system admins in the room, right? But we always joke as developers, we're system admins first until we could pawn it off someone else. Then we become back a developer, right? And so then they look at us and are like, what the heck did you guys do? There's no security. You turn off SE Linux and everything is running everything, right? There's no security. You're using the same passwords wherever, right? Why is everything running as root, right? Right? So the people, when we were saying, like, let's give a good sandbox, and this whole DevOps, self-service, cloud-native world we want to give is a nice sandbox for experience to the developers, right? So what we did, and there are tools out there, this happens to be Red Hat's tool, is what we do is that when you check in source code into Git, the tool automatically takes the source code, knows what type of software it is, and automatically builds a Docker image to spec. So you don't have to learn about SE Linux, you don't have to learn about single sign-on plugins, you don't have to learn about any of that. All you do is you give source code, commit source code into Git, and somehow magically it gets deployed on out into production, right, or whatever environment, right? Now, this is what, to be honest, this is what a lot of DevOps people do today, right? They write Chef, Puppet, Ansible scripts to go and do all this magic, right? And they write all these plugins and blah, 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 right? But there are companies like Red Hat that are out there that have kind of automated that full process, right? Instead of you doing some bespoke thing, right? So that's the idea here. Just that's on up there. Now, that's it for what I have for lecture slides, right? So what I want to go do is move to the lab, right? Because this is where you get to really play with Docker itself, right? So I think we have enough people in the room. Right. There's going to be a URL. If you go to this URL, master.calpoly.openshift3roadshow.com/console, right? You're gonna come up to a web page, and I'm gonna go around the room and give you a username, and then you can follow through the rest of the lecture, right? Wait 1 second. So I'm going to also give you is a second URL. So there's going to be another one. This is where the labs are. It's called labs. Just copy the URL, the first part of this, right? And there are 10 plus labs, and it starts from how to install the client, exploring the web console, deploying your first Docker image, clicking to go and scale the environment, right? This typically takes, like I mentioned, usually around here is about 5-6 hours for you to finish all these labs. Obviously, you're going to be only here for an hour, right? And then I have to be like Cinderella and also leave too. But you can use the environment for the full day. Tomorrow, unfortunately, it will be gone. So it's as much as you're going to spend your time in it, right? So this is where all the labs are. The other page is where the instance is that you log on in. And I'll walk around the room and I'll give you as a username, and we'll go from there. So you're user 01, user 02, 03, 04, okay, 03, 04, 05, 06, 07, 08, 09, 10, oh, this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? So that's user, whatever number that I get, and then your password is OpenShift3, right? So if you go back here into
Capital at all, or?
all lowercase. So you'll when you see the console, it'll have this login here, and this is where you type in, like, say for instance, user 10 or like 9, user 9, and it's OpenShift3. And if you log on in, it'll let you into the environment, right?
And then what was the other URL?
The other URL is where you do the labs. You should be able to go all the way at least to scaling. I'm hoping that you guys will go to at least a Docker scaling labs.
Not the other one. I'm not.
Okay, so this one, master.calpoly.openshift3roadshow.com. Who cannot get to this website? Gentleman in the back, you can't seem to get it? Oh, master.calpoly.openshift3roadshow.com. Did you try HTTPS? Yeah. Just go advanced, because it's a self-signed cert, you gotta go and do the exception. Right. Anybody else?
Having trouble with the other URL.
Oh, okay. Let me fix that. There's a.
Maybe you put it.
You had it right. It's just I don't know why there's an L in front of it.
Oh, is it? Yeah, okay.
My name's Albert. Okay, yes. Push advance.
Oh, okay.
And then set the cert at the bottom. Yes.
Then I put number 3.
Oh yeah, and user 03 OpenShift3. All right. Who else has problems?
It's not showing up.
Okay. I think that's let me see about the other one.
Okay, so this is just logging in.
Oh, it's a hyphen after the. It's not another dot.
Just regular OpenShift, right?
All right. Who else has problems? Other people? You're good. Good. All right. So I'm going to act as a proctor going across the room. So anybody, like, you just read things. It'll describe how the environment's set on up. You just go through this exercise as fast as you can, right, at your own pace. And then if you run into an issue, then you go and flag me down, and so that I can help you go get past through those issues. For the people without laptops, I thought they were going to bring is laptops for some of the folks. All right, so if anybody wants a laptop, they got extras.
How many do you guys need?
1, 2, 3.
3 laptops? Cool, I will get some.
All right, awesome.
That's what's in the file. That's
So I forgot what to tell you for the guys who are interested about what the lab is. So the lab is that the goal of the lab is to crawl, walk, run. So what you're going to go do is to sort of say, hey, I have a Docker image. Let's download this and just deploy it on out, and I will scale this. So that's the first thing. There's an image, there's an application that's built out in internet land. I just want to download it on my machine and just deploy it. Then the next scenario is I've got source code. Now let's build a Docker image from scratch, right? And you'll see how that process is run. The last scenario is I've got a n-tier architecture. So I've got MongoDB, I've got web servers, I've got different types of tiers. How do I glue all these tiers together to make an application run, right? So that's kind of the three scenarios that you'll do if you complete all the exercises. There's also a bonus section at the very end if you want to do DevOps, CI/CD with Jenkins, and see how the entire build process happens from that standpoint. But I'm hoping you guys will at least do the first one, so you can get a feel about how Docker actually runs. It's trying to just add that file into your class path, your path file, so you can just type it in anywhere.
Oh.
If you don't need to, you just have to navigate to that directory all the time.
Okay. Well, it's on the desktop. So I can do something. Okay. Verify.
It's gone. It's gone. It's gone. Yeah. Yeah. Just move it to user management. Then you can achieve. Yeah. That's good? Yes. All right.
Okay, so I need to.
All right. You okay?
Oh, yeah.
Oh, you're going to have Ned explain that.
Just go to the navigate. Yeah, navigate.
Were you not aware that there's laptops to? Yeah, yeah. I was just curious. Did you get to know that?
How do I?
No.
Oh, it worked. Okay. All right.
Oh, okay.
Okay.
This lecture sucks, man.
Yeah. All this
What am I gonna do? Type a bunch of like, system control commands up on the screen for you? It's not fun if I just do it. You don't learn anything. We got laptops.
Cool. We need the laptop.
I think I'm doing this right. Trying to export the path. It's just saved on my desktop.
You know, the easiest way, just copy it to user bin. Because user bin is typically.
How do I do that?
CP, right? The last person.
Okay. Okay.
Because
The
user
password
bin's
for the
already-
laptop
Right.
is CPP.
You have the plug for this?
Check if it's there. Okay, now I'll go upstairs and
Should be able to do it.
Still gave me the no.
No.
Well, okay, I'll-
What was the password? CDP?
What's it called? This one that actually tells you all. That's good. That's good. Cool. These are local bin.
Okay.
One of them was recommended by.
Okay, cool, thank you. Oh, I see.
We have a project there just for you to explore. So we kind of put a project there so you can kind of.
Sorry,
play
yes,
around.
good.
Okay.
Thank you.
Oh, I also have another question.
Yeah.
After today, like, sorry, how do I get rid of all of it? Or do I have to manually go in and sort of?
No, you just only delete the OC command, that's it.
Oh, okay.
Because that's the only thing that's installed on here.
Oh, gotcha. Thank you.
What's the second URL?
The second URL?
Yeah.
Yeah.
Let's
So,
see.
That's very similar to the AWS CLI client, if you ever
Oh,
installed
okay.
it.
Oh, we're already on that. First thing we want to do is.
It was only available to midnight?
Sometime early next morning. Yeah.
Already on.
Permission free.
Okay. Already there. Oh, we log in. Yeah.
No. You'll need
We're supposed to do a bunch of stuff. Demo tools. Yeah. Yeah. What? Okay, so I already did that. Okay. Yeah, that's why we already did that.
For the people that are using Macs, if it copies you user local bin, then you don't have to modify your path.
I know, I realize that.
Oh yeah, well you're, you mean this one? Oh, this one?
No, the error's gone. Because I refreshed the page.
That's right, as long as it's the same here.
That's acceptable. Yep. Yay. Yeah, not instead. Binary and license and what do I have? Text. Text. Play first.
I'm sure when the other person shows up, I'm sure it happens. I don't need to.
Yeah, you could if you want. That's only for the people that are like, want to learn from anywhere, right? Or
Several options from your own to deploy copy and paste. Okay, we did that. You're going to wind up with your okay. So just continue. Either press enter or click on the magnifying glass. Winning.
I'm just surprised you guys are here. This is Swift guys don't usually show up consistently.
Well. Well, we're here.
That's good. It's good. Because I don't see you guys or the Missa folks typically show up in a systematic.
Well, we're here.
We really don't have like a lobster-like club.
It's interesting.
Yeah.
This would have been really helpful.
Is it slide deck available for any of us, or is it proprietary?
No, I can send you it.
Okay. Would you like my?
No, why don't you email me? I'm just albert@redhat.com.
Okay.
Albert, that's it. ALBERT@redhat.com. No last name, no nothing, just albert@redhat.com.
Okay, thank you. I'd like to take a look at it.
Okay, well, let's find out what we do. Okay, did that. If we create, okay, create.
Why is this already?
Yeah, it's logged in. You logged in already, you have that page. You don't know how creepy that can be. What? I don't know if I refreshed it. Go back and back. This. It didn't refresh. Next time we have
Where is the OC?
Odds contain containers. Containers contain. Yes.
Hey Albert.
Yeah.
Will I be able to add OpenShift on my resume after this?
I think so you'd be able to talk about it. You're gonna have to do a little bit more.
Is that a call gosh darn?
Sorry.
Is that one of those responses you would say?
First thing about that's a good.
So, you know, while you guys are still doing this, let me talk about some of the people who are using Kubernetes in production today, or Kubernetes and OpenShift in production today. So we had Disney who uses it for the rendering farms, for stuff like that. DreamWorks also uses it. FICO. Basically anybody who is moving towards a cloud native world, it really means Docker. And right now, although there are competing orchestration engines, so there's Docker Swarm is also the one made by Docker itself, but people really like is Google's version, which is Kubernetes. And so Red Hat happens to be the largest contributor of source code to Kubernetes other than Google, and we're the largest contributor of Docker source code other than Docker. So this is the pros and cons about open source, is that we can also take the source code ourselves. We can put developers on the team, and we can build and enhance it in our ways, right? And so we build essentially, you know, our variant, but we also submit that code back to improve it. So for us, it's, you know, with almost all our projects that we work on, or all the products that we go and support and sell, we really, to Red Hat, it's not enough to just sort of say, hey, yeah, it's open source, blah, blah, blah. No, you need to actually have people who can fix the code if a problem does arise, right? So this is the value that you bring, is that who owns the developers is the people who are going to buy support contracts with. Because why are you going to hire a company and then you ask about a problem and then they're like, well, we don't have a guy who knows that component, right? So that's one of our things. Also, if you want to run this at home, if you go to openshift.org, you can get this as a Vagrant image, or you can actually get it as a VM, or you can install it from source or from binary. So yet again, all this code, this environment, you can install it here. Now, there are plans apparently in the academic program in 2018 will switch to this at Cal Poly. This will be the base environment for, I think, the third years.
Good.
So I don't know how much of that has been all baked, because there's also an OpenStack environment that's being built too. So because the cloud native world is really becoming, no one's provisioning normal servers.
Right.
Because a normal servers, that's like 10% or 15% of the work for you to build a full app, right? So what, you've got an OS, but now who does all the customizations, right?
Right.
So, and then the second thing is like building a virtualization farm also is not good enough, because now you're like going, that doesn't get me to AWS. That just gets me an ability for me to snapshot an image and deploy that, right? So the strategy is, if you're a VM shop, you're moving to OpenStack. If you're going true cloud native and you're competing with the Googles and the Facebooks and LinkedIns of the world, you're using containers. So this is kind of the two standard operating environments that's moving in the future. You're either going to be VM-based OpenStack, or your containers, you know, OpenShift type of thing environment. So the curriculum is supposed to be being written right now, the new one, for 2018, 2019. Scale means to make multiple nodes. So this one here means like you have one record node. So every single time you hit the website, the load balancer is a one load balancer, one process. If I scale to 2, now I have one load balancer, and I have 2 instances. And then it does load balancing. So it hits the first server, then it hits the website again, hits the second server, it's like clicking, so it has the first server. Right? So if one of them fails, you still have one that's really running. So scaling is a term that we use to scale, make, expand the capacity of the environment. And you will see that when you run the command, you'll see that now there's brand new. Right? And if you do OC get 5, you'll also see it's 2. Right?
actually creation. So what happens there is 0, 1 because it's being provisioned. It's not live yet. So if we type in the command, now it should be 1 of 1. Right? It's creating it. It's not. But it's in creation. The health check has not passed yet, so it's not moving to the load balancer yet. Right? Do you know what I mean by load balancer?
Yeah.
Okay.
No.
Okay.
No. Thanks, Mike.
Think about it, it's easy for you. If someone says, I need 10 instances, just go with OC scale 10. Right? Yeah. Just type that. And if you click on that 10, you just had 10x capacity.
Why don't I just sit over there? Can you sit over?
We're not moving.
All right, give me 1 minute. It's like fatal. This can be good. Or is it just still loading?
No, what's it called? OC get not RC, but pods, right?
Well, I'll show you the one. It says OC get RC. That's what I did.
Oh.
I used to.
Yeah.
Oh, okay. So it's just taking time.
No, this error typically happens is there's something with your Go library, Go install on it. Yeah.
Yeah.
If you read
There you go.
usually means that there
Never
is,
thought of it that way. Thanks.
there you go. I'll send you everyone having to update the
One hour.
Okay. Because everything's up to date, so I don't know why I'm getting.
Now I can visualize it.
Well, the thing is,
Thank you.
I'd have to look at the stack.
Okay.
So,
All right. I'm gonna screenshot this. Would you like me to send it to you?
Yeah.
Okay.
Or cut and paste. Don't screenshot it, but if you could cut and paste the material,
Well, I was just gonna
then I can at least
Okay.
That'd be great. Who else has an issue?
Okay.
Thank you.
Yeah.
So, am I supposed to be able to access it on
Yeah, so, no. So, okay, so the way it works is that there's actually a port mapping that's happening. So what happens is that the container is running on 8080, but the load balancer is coming in at 80 and it's spraying to multiple containers, right? And so this is what happens is that when you're getting these IP addresses, you'll notice that that's not the real one. You'll notice, let's go back. So, no, go back to the console. This one, yeah. So let's just go back to the overview. So here we have one pod. If you click on that one pod, right? Click on that. Right. This is where it says it's 80, right? Now, what happens is, so actually it has multiple IPs on it, right? So there is a IP for internal network traffic between the containers themselves, right? And then there is a kind of an IP that's glued to the load balancer. But you don't access it, right? The name that you get, actually go back to applications, or Sudo Access. Right? Oh, you're not there yet, but when you get further, you'll be getting is the load balancer name.
Oh, okay.
Right.
So this is simply just for free.
Yes.
In our own data center.
This is your idea. So you can you're a little bit like get to the end of the scale lab, like lab 5, and then you'll see everything else flushed out now.
Well, wasn't there like a limitation of like a gig or something? Is that
No. So here's the idea: is that the limitation of gig is not a limitation. The idea, the philosophy of DevOps is that you want to scale as small units, right? Because if you think about it, is that you know infinitely horizontally scale. Actually, you can scale to about 12,000 containers in one environment. So the idea here is that if I only chisel out half a gigabyte at a time, I can efficiently shrink and grow in that type of increment. If you have a machine that typically you'll have an 8 gigabyte VM, it's 8 gigabyte, 8 gigabyte, 8 gigabyte, you know what I mean? Problem is you can only move up and down in that that level. So you don't have that microfinite. Right? So you're much more efficient in resources. If one machine, one cow is broke, it's only going to affect this half a gigabyte. Right? So it's all this type of philosophy.
You have multiple like web servers, like what load balance?
So if the one that's contained in this is AJ Cross. Right? So that was the one that's being used. A lot of people use Unix because they like it in that sense. You can do it, but there are pros and cons of each one. Right? So it really comes down to requirements. But the thing is, for dev guys, right? It doesn't really matter for us, right? Well, what matters for us is that when a service, when a container turns on, right, we have to make sure that the health checks actually pass, right? Because the thing is that you don't want to throw a web server that's giving a 404. You want to make sure it's 200 all the time, right? So starting up a process, it takes whatever it is, right? And then make sure that the application database gets preloaded, and then you go and turn it live. Right? These are the things that are most important to us. Then the other thing too is that we want the external view. So did you help? Did you click on the Heapster? This popular thing? Oh, yeah, okay. So this got done right. If you go back here, go to there should be is when you go and click on the overview, there should be an additional you get MIPS and memory data.
Oh, that's weird.
Right?
Okay, that's
and so the idea here is that we don't freaking care if the environment is burning hot. What we care about is the APM response at the front end, right? Because that's where we lose customers. They say that for every e-commerce customer, for every second we lose something like $40,000. Whatever it is. So people want fast. We don't care. It doesn't care if we've got the burn infrastructure. If you ask anybody from the sample who runs the e-commerce site, I'd rather burn $100, and if it takes me $99 of infrastructure, who cares? I made a net profit of $1. Like, net profit is what's most important. I don't care what the infrastructure costs me. Like, I will figure out how to optimize it to fix it to get a bigger one, but the most important is make money. Right? Not like, so you can't be like, you don't want to join, that's why I tell people, don't join a company where they're nitpicking on like tools or whatever it is, because that means that they're in the optimization phase. That's a bad spot, because that means that they want to go and not, gain new market share, find those, all they care about is trying to save money. When you save money, then you're like, well, I'm not going to go and do all these great things, right? Yeah. Anyways, keep on going. Ask me in 20 minutes when you get through that. Okay. So connect to the pods itself. Okay. So the idea here is that you have to use a row. Okay. So you got to remember that the containers are actually behind is a router. So those are not real IP addresses. They're not accessible for you on the internet from here. So for OC, because the OC command is a little bit unique, you can go OC SSH, and it gets the container, right? But we typically say that's why would you even bother to go to something like this? Why don't we just go back? Where's the this one? We're going to the pods itself. We're going to bar. Right. Now, for us, right, we don't like to go and shell into a container. Anything tested in the container, right? It's ephemeral. So what happens is that you lose all the settings. The correct way is to check in the changes backstick to source, whether it's an admin task or a dev task. Then the next CI/CD process is build and create brand new ones.
This is what
I
I
mean,
got.
so we only
I should have
maybe like see a log or whatever it is, trying to figure out what the delta that we missed in source control, right? Right, because the thing is that the next time that this container changes position again, it's on. Right. Just want to see what. And it's there's nothing in it.
Oh, there it is.
Yeah, that's the whole, that was the whole thing. I was like,
Oh, there it is. Okay. Yeah,
There's literally nothing.
We'll start that.
Because that's the idea of Docker itself, is that you only install minimum of your application.
Yeah.
Right?
No, I haven't typed
Small
that.
as possible. Small as possible. Because dependencies slow you down.
I know. I'm actually reading it.
Alright.
Killed it.
Yeah, okay.
It's like I was trying to dockerize Malware. Dude, this is a lot of stuff.
This is a lot of stuff. I'm trying to teach you about
You are thinking big fuel for the fire. This is bad.
I read Docker as a self-contained system.
If you could do this, you would have been paid for
I compiled it just one expose any trace of something that's located inside a Docker container. So I'm asking like maybe
Alright, you're good.
Yeah.
Good. Do you get to the parts of scale?
Yeah.
Scale
Your
it to 10.
imagination running wild.
You can go and
don't worry, there's already
go
an
back
app
to
that installs
Captain
Access.
Dashboard.
It's actually a
Minimize
registry for this.
Oh, that's cool.
I want to
You
touch
should
that
have it on
one.
the same screen.
No, you
Right,
don't.
it's a man, and then see how fast it converts. And then, yeah, we hold let's just move this just like.
No, it's just. I mean,
Oh.
Right, and you can see it actually open.
Oh my gosh. I can scale.
And then you can see all of them.
Oh, that's what it does. I'll take another one.
Fully scaled.
Oh, that's good workshop.
you haven't even gone to the good stuff yet. This is only typically like.
Oh yeah, I got that part.
This is only half hour into a 5-hour thing. You haven't gotten to the mind blown pieces yet. Okay, so we got 10 minutes. And I want to do a slight recap. So I want to talk a little bit about what you guys have seen, right? Now you guys can ignore me, but I want to go and talk a little bit about it, right? So it seems like most of you guys got to the point to actually deploy as a Docker container, and you got to see some of the scalability, right? So, this was the first piece, part one of the 3 pieces that I mentioned, right? Part 2 is that you got source code. There's a project on there that would be a Java project, a Spring project, and then you would deploy that on out. And part 3 is that you would integrate to MongoDB, and then with CI/CD and do this whole type of thing, right? So you guys have just a small, touch of what the container can go do. Now, what things that you can see about what the container is, right? So you kind of saw a little bit about the directory, right? You kind of looked for something off of Docker.io, Docker Hub, right? If you've ever gone to Docker Hub, there are multiple images on out there. The reality of the situation is that don't reinvent the wheel. Someone else out there has built as LAMP stack, mean stack, whatever else stack that's out there. We don't get paid per line of code here. We get paid to go and solve business problems, right? The faster you get to point X, right, is the more time you can be doing other things, right? So think about it in that time, right? So if there's someone else that's gone out there that's done it, go and get that code on out there, right? The second piece that you kind of explored a little bit about is you'll notice that the way that the configuration was really easy, right? The install process was really, there's only really 3 steps in Docker. If you look at Docker's instruction manual, there's only 3 commands. So there is Docker build, which is it builds the image, which you guys did not get to go do until the next part. The second part is a Docker pull. Docker pull means search in the registry for this image, like guest book or whatever it is, and then pull that image onto your local project. The third step is Docker run, and basically it's run the service, right? That is the 3 commands that you get out of the box with Docker, right? And you'll notice that it was also really simple. That binary image, you kind of saw it download and whatnot and provision on out. It's very, very simple for you to get it working on your workstation. It's very easy for you to pass it on to somebody else. You just give them the name of the Docker image and they're able to go and deploy that on out. And it doesn't matter if it's on your workstation, and it doesn't matter if it's on your server, and it doesn't matter if it's 10,000 servers. It's just the same, basically the same idea, right? The next thing you saw was the scale feature, right? Now, scaling is not part of base of Docker, right? Docker is just purely the engine, right? So think of that as like kind of like the application itself, whether it's the web server or the database or whatnot. All it is it just runs the process, right? You need is the intelligence, something that tells it to scale and whatnot, right? So that's where Kubernetes went into play. That's the command that you typed in was replicas equals 2, replicas equals 10, 20, right? That's where you actually do the scaling. But think about what happened with that one command. So with that one command, when you said scale to 2, it found is another node out in the network that had availability, downloaded the Docker image on there, turned it on, inserted an IP address into that, and you'll notice that there were multiple IPs. There's public IPs and there's internal IPs that was associated to the Docker image itself, right? Then it actually put all the images in its own VLAN, right? So every 20 of you guys, there's different 20 user accounts, you guys had your own VLANs that no one else, you couldn't access. If you knew even the IDs of all the other members of the Docker images, you wouldn't be able to even access any of those, right? Even beyond that too, you also had storage was provisioned for you, right? All these type of things was basically your own little sandbox, right? You were able to go and do all the things that you needed to go do, right? The other thing with the network, another thing with the network I wanted to go mention was that, remember that, what it takes in order to glue is a cluster member into the load balancer, right? So not only that it has to know the IP, it has to make sure the process is running, it has to make sure the service is running, and then I glue this into the load balancer, which is HA proxy, right? Next thing with the HA proxy, you'll notice that you had a name, right? I'm not sure if you guys got to that part where they actually created is a route. Yeah. And that was the public IP address that you can go and access it, right? And you'll notice that each one of you guys had your own process, but you guys didn't actually, step on anybody else's toes. You guys actually had your own sandbox with your own DNS name, and that worked perfectly fine, right? Did you guys get to the section where you were destroying containers?
Yeah, deleting them.
Right? And did you actually see it on the screen where you're trying to delete as fast as it was trying to reprovision? Yeah. Right? Yeah. The fun thing is if you write is your own bash script, and you'll see it try to delete, and you'll see it try to bring up, and the next thing you need to go do is actually click on the page to refresh and see if you can get a 404 error. Right? That's one of the little interesting things. You basically, think about it. In less than an hour, you've learned the basics of building a lab stack, and you've already built is a resilient system. something that you can scale to. If someone tells you like you're very popular, we love your site, but you have capacity problems, you're like, sure, let me do some magic, right? Type in a few commands, actually only one, and then the next thing you know, it's like you've got like triple capacity, 10 times, 20 times capacity already available to you, right? If someone also asks you to sort of says, hey, you know what, I need to go and deploy this in another sandbox, you can go and easily go and do that. You can create another project, and then just put your own other sandbox, different URL, whatever, which ones you have. Most developers will have 3 projects, right? Current build, right? The environment I'm working on right now, whatever's in production, so I can go and fix bugs, right? And then whatever is a prototype that I'm working on, right? You think about that, that's really common, right? We have multiple sandboxes, but we're restricted as developers. In the old world, we're restricted to only our laptop, right? And in our laptop, we can't have a fully clustered environment. You can't just provision 20 instances and it would just, you'd be able to go and test that, right? So in a developer environment, what are our problems? We can't get our environment, we can't request the environment that we need. We can't scale it to figure out if we have any type of, clustering type of issues, right? What's the next thing that we typically ask, that the developers ask? Get me the logs. I need to know if the health of the application is working. You get that all through the console itself, right? You don't need to go bug some admin for all these features, right? Or all these things. So this is I want to give you a glimpse of this is what companies like Google, the Facebooks, the LinkedIns of the world have already been doing for 3-4 years, right? And you're only 30 minutes into a 5-hour thing. Just think about that, right? 30 minutes into it, right? And they had this 4 years ago, right? So a lot of things on the feature, unfortunately I don't have time to go show you all the really fancy, really cool things. But just know that this is kind of the industry you're going towards, right? For the system admins, when I was going to school, the admin to developer ratio was 10-1, right? Meaning that admin usually managed 10 servers, right? Mid 2000s, it moved up to about 100. At Google, it's 1 admin to 100,000 containers. 100,000 containers, right? So this is the scale that you guys are managing, and then they use tools like this, right, to go and do it. So let me also break it up in another way. The admin tool that the logging tool that you saw is very analogous. It's actually called the F-stack. E for EFK. You also might hear out in the industry ELK, right? So that's Elasticsearch, F for Fluent D, and then K for Kibana. You saw the Kibana interface. Splunk is the commercial equivalent of that. The monitoring system that you saw is very, very close to something that looks like from New Relic, right? That's how it kind of looks, right? What it does is it attaches it to the process, to your source code, or you add a little library into your source code, and it instruments your code, and you get metric data from how your application is performing, right? Containers-wise, Kubernetes is what you would typically see from Google Cloud, right? And then from the load, and that's also with the load balancer, the network, whatnot. You basically, so almost all, this is kind of how Google Cloud all works behind the scenes, right? In a very, very large scale. Anyway, my time's up. I might stick around for another 15, 20 minutes. Welcome to ask me questions. My email is albert@redhat.com. Feel free to email me. You'll have this environment for basically tonight or early tomorrow morning. It'll actually go away. You can download the software, this full environment, on OpenShift.org. You can get the community version of the software, install it in your own servers, right? You're probably going to need a minimum, 1 master and like three nodes, so you can see how the containers get placed in the environment. Play around with it. Thanks for coming. That was good. As much as, yeah, I mean, it's kind of hard to go through, an 8-hour day, especially they only have to play with it for so much, right? So at least gives them a taste. Well, I mean, we talked a lot, but I think so.
good with that. I mean coffee and tea. Yeah. Sugar. Oh yeah. My thing was first. I met Jessica. We'll do our formal introductions in a little bit.
Can you see it from the back?
So let's get started here. Thank you so much for inviting us out to Cal Poly Pomona today to talk with you about InSpec, an open source project from Chef. I'm Jessica DeVita. I'm a technical evangelist at Chef Software, and I'm joined today by my colleague, Ned Harris.
And I'm a solution engineer. I guess they changed our titles quite a bit, but that's the latest iteration of my title is solution engineer over at Chef.
Cool. And you've been working with InSpec for quite a while, right, Ned?
Yeah, pretty much from the inception.
From the beginning.
Yeah.
Very cool. Very cool. Well, today we're going to talk about a project that's going to let you be able to really know what's going on in your infrastructure, regardless of how it was built or provisioned or what have you. You can use InSpec with Puppet, with Ansible, with, like whatever. It doesn't really matter.
Even with Chef.
Even with Chef. Imagine that. It's a Chef product. So, but to start our workshop today, we do have 2 hours, and we are going to crank through some labs, and it's going to be fun. But to make that even a better experience, I want you to join our Slack channel. So on your laptop now, go ahead and pop over to community-slack.chef.io. And when you get to that page, you'll have a prompt to enter your email address. And when you enter your email address, you'll then go and check your email. It will allow you to establish a Slack account with your username and password. And then you'll need to find the channel. The channel I set up for us today is Cal Poly Pomona-InSpec. So we'll take a few minutes now to get everybody signed into Slack.
And let me know if you guys are stuck in any way, and I'm here to help.
And are you recording or live streaming? Both?
Yes, live streaming, and then that reports to YouTube.
Oh, cool. Very cool. We should get the channel so we can share it out too.
A link? Do you want the link? So
that would be awesome.
Do you want me to just put it in the Slack?
Yeah, if you could just drop it in the Slack channel, that would be great. If you've gotten yourself signed up for Slack and you're all set there, The next thing I'm going to have you do is to navigate to this URL. And once you bring the page up, let's take a quick. So that page I asked you to bring up contains a whole bunch of IP addresses. And basically, we're going to go through, and just from the top, it starts ace of diamonds. Okay, so everybody's going to take the proper IP address. Okay, so we're going to start with you. So you are an ace of diamonds. You're having trouble with it right now? Okay. And so basically, we're going to get these IP addresses assigned to each of you. So count off from the top. So for now, just take a note that you are ace of diamonds, and you are going to be jack of diamonds. You're jack of diamonds, okay? Hi. You're going to be king of diamonds, okay? 2 of diamonds. 3 of diamonds. You're going to be 4 of diamonds. You're not participating. And so 4 of diamonds, 5 of diamonds, 6 of diamonds, and then 7 of diamonds, 8, 9 diamonds. Okay? Yeah, so take a note of your IP address, copy it down, write it down so that you'll have that. That will be yours for this session. And just a quick switch over here. I just want to show you what we're going to be doing with that IP address. You're going to use an SSH client. If you're on Windows PuTTY, for example, but you will SSH, the username is chef, and then the IP address. You'll press enter, and you'll get prompted for a password, and the password is chef, C-H-E-F. And once you get logged in, then that's going to be the lab machine we'll be doing all of this work from. Okay, so no need to install anything on your workstation right now. Yeah, so I brought the link back up with the bit.ly link for the IP address distribution. So just a thumbs up if you've got your Slack and your IP address all set. Thumbs up. Awesome. 2, good. 3, 4, 5, boom. So, all right, well, just let everybody else get situated there, and we'll help you if you get stuck.
You're going to share. Okay, you're going to share. So just so you guys know, this link is in Slack. So if she clicks ahead, you can go back to Slack if you lose your place.
Do you need the door closed?
new folks joining. Hello. Let me get this.
Password chef.
Okay, so for the new folks who joined, I'm going to have you go to this IP address, bit.ly, this bit.ly link on the screen. And let's see, we stopped at distributing after 9. Okay, that's right. So, what else do we have? You joined. You just joined, right? Or you've been? Did you get an IP yet?
No, I'm
Okay.
setting one up right now.
You're grabbing one from this bit.ly right now?
No, I'm turning
Yes,
one
spinning.
off.
Oh, you're still signing up? Okay, good. So we'll just wait a couple more minutes for folks to grab it, get signed in.
Just a show of hands, who does not have an IP address yet?
And then the other thing, in addition to getting an IP address, so you're gonna take the 10 of diamonds when you get signed into that gist. When you go to this link, there's a huge list of IP addresses, and you're gonna find the one, the 10 of diamonds, and that will be your IP address. And if she comes back, she's gonna be the 11. Is it 11 or Jack? Jack of diamonds. Jack. You can tell how much I spend time playing cards all day long. Okay, so just a little bit about our company. You probably all know about Chef. Hopefully you're here because you're excited about the technology. But we're really happy to be here to share the good news of the projects that we're working on, most of which are open source. And just to know that there are great companies in the world that are using our tools to build amazing products that you probably use every day. And they're using that, and the way they're managing those IT assets is really changed by way of Chef. And so we can see some examples where, in this example, a customer was able to patch 250,000 nodes inside of 6 hours. Like, some of the things people are doing with Chef, it's all about speed, being able to go really fast and be really safe at the same time when you're talking about how do you manage IT and infrastructure and how do you do all of those things successfully. We have a very large bank that I cannot name who is in the middle of their adoption of Chef. And I mean, you saw this, right, Ned? It was like how many, they had a few nodes going under Chef, and then Shell Shock hit, right?
Yeah, so basically we were doing a proof of concept. So in the proof of concept, we put Chef on about 7,000 nodes out of, I think they had, like it says there, 60,000, or 2,200 nodes out of the 60,000. And basically Shell Shock hit right in the middle of our POC. So they're like, wait, we have to stop this POC and go deal with this. Well, at the time, while we were working on that, we had basically remediated the 2,200 nodes, inside of 15 minutes because we actually had the Chef client going, and we're able to just identify. That took 10 minutes to identify all the nodes, another 10 minutes to remediate. At the same time, for the remaining nodes, as it says here, 156 people and 9 days.
Incredible.
Yeah, so it was I think we won the POC.
I think so too. Yeah. And again, all of those tools are built on top of our 3 open source projects. We do have a commercial product that customers pay for called Chef Automate. And we're going to see a little bit of Chef Automate today because it helps illustrate the value of all of the open source automation that we want you to be familiar with. Today our focus is going to be on Inspect, but through Learning Inspect you are going to see the entire life cycle of test-driven development, remediation, and basically seeing your change go through a test cycle. And this is setting you up to understand those best practices as you go into the workforce and how you think about software development and infrastructure management today. You know about Chef, right? Some of these we've done some workshops out here to get you up to speed on the basics of Chef. We will be doing a very little bit of Chef today, and it should just remind you of the work you've already been working on. We are going to see, again, that continuous compliance where we have a scan that shows a problem, we fix the change, and then we see it remediated. And lastly, but not least, is just this notion of visibility on the fleet, across the entire fleet, and what can you really know about your infrastructure at that point. Again, so that we're going to dig in today on the inspect testing framework. We're going to understand how this language, this very easy to read, human-friendly language will be used to actually prove the state of your infrastructure in a read-only sort of way. You don't want the same software that's applying policy changes to your nodes to be the same machine software that determines if it's compliant, right? Those need to be separate functions. We're going to show you how to do all of that. And again, ultimately, what we're driving for is something called compliance as code. So instead of auditors handing a PDF document and say, here, go forth, Ned, make those systems so, and then Ned is free to go and hack together some shell scripts or whatever he's going to do.
Or just throw as much paperwork back at them as they can as a defense mechanism.
Exactly. And so we want to give you a better way to not only ease the life of the sysadmin and the operations team, but the security teams, but also the auditors, and just really give you a common language that everyone can start speaking. Like we talk about how DevOps brings teams together, and this is an example of an automation tool that brings teams together. We'll also be covering a little bit of Test Kitchen. Hopefully you're excited about Test Kitchen and have been able to dig into using that. It's one of, right? People joke that, you buy Chef, what you're really buying is Test Kitchen because it's so great.
Yeah.
And so with that, I think we should go ahead and get started right into our hands-on labs, okay? So each of you should have been able to get an IP address by now. Did you get one?
Yeah, I did.
That's all right. We've got one for you. I'm going to pop back on the slides here and first of all ask you to get signed into Slack. So we go to Slack, community-slack.chef.io, and when you get to that website, you'll get an opportunity to enter your email address.
And again, at any time, if you're stuck or need
Raise your hand.
just raise your hand, I'll come running.
We'll come around. And then I just put the link up for you to be able to get your IP address. And she's going to be Jack of Diamonds, is that what we just said?
He's the Jack of Diamonds.
He's Jack of Diamonds, okay.
Okay, so
Great.
she needs
So she's going to get Queen of Diamonds.
Someone was asking about the password to SSH, so it's just lowercase chef. In case you, I didn't want to type that in Slack. Call me crazy.
How's it going?
Very well yourself.
Very well, thanks. So we're going to get you signed into, if you have a laptop that you'll do the labs with us, we're going to sign into Slack.
What's Slack?
community-slack.chef.io.
And to answer your question, Slack is kind of a chat program for people to basically communicate with.
Like that Hangout app on Google?
Similar.
Similar.
Oh, you know what? Right there. What's that bit.ly link?
Well, if they can get there, they have the bit.
Oh, it's in there, right?
Yeah.
So it's community cheese.
hyphen slash .chef.io. That's the sign up page. The actual team name is different. But this is the part where you get the invite for yourself.
Gotcha.
NZW.
So you don't want to get my invite?
Yeah.
Yeah.
Gotcha. And so just put my email?
Yeah, just give it your email.
It's secure, right?
Yeah.
Okay. Manual design.
No email provided.
Oh, I'm supposed to sign in, right?
Yeah. So see where the link is? Okay. So what's your card?
I know the nose.
Okay. So you'll be King of Diamonds. Is that what we're up to?
Queen of Diamonds.
Oh, you can use Ace of Diamonds then. Yeah. So the first one. So just copy that. You got it.
Okay, so for password, just any password?
Yeah, it's up to you. Just something secure. And for those of you guys signing up for Slack, this is something you could use for a lot of other purposes too. There's a lot of Slack channels. What we're putting you in is the community Chef channel, which is a really good place to ask questions in the community about Chef in general. So it's definitely something that you can hold on to after this class.
Great. So you've got Slack and an IP, right?
Yes.
Great. Awesome. Cool. So let me get back to where we're going to start. So again, this is kind of the workflow, that the shape of the work that we're going to do today. We're going to begin with a compliance scan. We're going to make some changes and build and test those changes locally using Test Kitchen. And then we're going to put this is the sort of shape, right? We talk about test-driven development, and that begins on your laptop. In this case, it begins on the VM that I've given you that you're connected into. And again, we're going to use Test Kitchen to explore those changes. So everyone go ahead now and log into your machine. So SSH chef at the IP address. And once you're logged in, you might be prompted, are you sure you want to continue connecting? And the answer there is
yes.
Yes. And then you should be prompted for a password, and the password is chef.
Now, if you're on a Windows machine, you're going to be doing this through PuTTY, just so you know. So this, what you're seeing here assumes that you have a Linux Unix terminal,
yeah.
like on a Mac.
Is everyone able to log into their machine?
Still working on it. Gotta create my account.
Okay. So once you're logged into your machine, let's go ahead and run a quick command. We're going to type the word touch, and then your first name and last name. And we're doing this so that your machine has a quick little text file with your name on it. And that way, when you run an ls command, if you see anybody else's name besides your own, then you're logged into the wrong box. So let's go ahead and do that.
And I've seen a lot of people do this, so I'm just pointing this out as a precaution. It is your first name dash last name. Don't type first name, last name. Because everyone sees that and you just tend to
type your actual name.
Yeah, type your actual name. Yeah, I'm sorry, the key. Oh, sure. Okay, this one.
And then go ahead and ls and see that your file, you don't have to type all of this. You can just do ls and see that your name appears there and no one else's. Thumbs up?
Yeah, sure.
Good? Sweet, thank you. So the machine that I've given you has a few things installed on it, but right now I just want to, let's get comfortable with seeing, what version of InSpec is installed. So go ahead and run the command which InSpec. And the output should just show you the path where InSpec is installed. And let's go ahead and take a look at the version of InSpec that you're running. So if you'll run InSpec space version,
I don't know why I type my email, but it won't. I check my inbox and stuff.
So this actually go to community chef.io.
And your version is probably going to be out of date. It's probably going to give you a warning that you're out of date, and that's okay for the moment. But it's nice, it does let you know what version you are and whether there's any updates to it or not. The other thing that we've installed is the Chef DK, the Chef Development Kit, which contains all of the tools that you'll need to write chef code, write inspect code, test kitchen. All of those great tools are bundled inside of Chef DK. So let's go ahead and ask the system which chef is installed. So you can run which chef, and it's just going to show you the location where it is installed. And if you run chef space -- version, that will indicate which version of chef client or Chef DK that you're running. So a little bit more about that Chef DK. I talked about how it contains sort of all the tools that you'll need to be an awesome sysadmin, but let's understand what they are. Food Critic is part of Chef DK. Food Critic really looks at your chef code against how the community views the best practices are about writing chef code. It can help you, enforce certain compliance practices. Cook Style, which really just looks at your Ruby code and, is this good or is it bad? Looks for unclosed strings and things like that. Chef Spec lets you simulate your chef code. And then Test Kitchen, which is that really awesome tool that lets you validate that not only that your recipe works, but it results in the system state that you intend it to be. And then finally Inspect, which lets you verify your automation, again in a read-only way, and confirm that your chef code didn't produce the wrong thing, or override and open a port that it wasn't supposed to, something like that. So we'll pause a second. How are we doing? Slack, we're good? How are we doing? We're good there?
We're getting caught up.
Okay, cool. And once he gets in, we just, which chef, which inspect.
Yeah, I'll get him.
You'll get him through to that. Fabulous. So I want to talk a little bit about continuous compliance and what that means for you from an inspect perspective, and what does that mean. So let's also take a moment now to open a browser tab on your local laptop and navigate to https://calpoly.compliance. I'm going to put the URL in the channel, okay? Actually, 1 second.
But you can try. Or you could do like every first name, last name, or first initial, last name. That's probably safe.
Okay, I've placed the link in the channel. Go ahead and try to get out to that. Everyone able to log into Chef Automate? Okay. The username is Chef. The password, I believe, is not Chef. I think it's the word Manhattan, all lowercase. But let's have everyone log into the Chef Automate server. When you get to that page, it might prompt you that it's a self-signed cert, so you click down on Advanced and accept it and navigate through to that page. And there are more of you than there are of me, so be sure to help your neighbor pair up, sit next to somebody. We'll begin to experience the value of the chef community, helping one another as we all learn. Once you've logged into Chef Automate, I want you to browse to your nodes. So you're going to click on the Nodes button at the top left. And when you do do that, you're gonna navigate down and find your machine. So remember, you know, you're the jack of diamonds, you know, you're whatever, exactly. Find your machine in the list. And thumbs up when you found your node. How many people do we have on the live stream? Anybody joining? Hello, remote people. Manhattan.
Yeah, go ahead. Okay, yeah, there you go. So see, there's your, not there, marker where this is.
All right, who's found their node?
Yeah, there's your picture. Yep. Do you remember your card?
Okay.
Okay, we'll get you in. So you scroll down.
I'm sorry?
What was the username to log into that?
Chef.
We're gonna give you 3 of hearts. So 3 of hearts is this piece. Copy that. Over here.
Thumbs up when you found your node in Chef Automate. 3,
Okay.
4,
And then, so do you have
5,
Putty?
6.
What's Putty?
Putty's an SSH client.
No.
Okay.
7.
If you hit your Windows browser and you said run button. Okay, down here.
Oh, yeah.
Type search, type Putty. PU. Wow, that's not really responsible.
Okay, great.
Okay,
So browse to your node, find your node,
Okay, so
and
that's-
take a look at that.
Alright, so
Let's
something
view
up
the
around it.
details of that node. So if you click into the
Yeah,
node
new
detail
tab.
page,
And just type
kind of, you know, look over the page and see what, all the great information you can find about it. It's gonna talk to you and show you, not gonna talk to you, but, that would be funny. We can see when the last Chef, convergence ran, when the last time the Chef agent ran on that box. We can see a lot about its, platform, and things like that. We can actually look into some of the run list. We can see the attributes of the node, expand all of the attributes. Remember, all of this data comes from that OHI that runs on the box every time and tells you everything about the node.
Is this on the AWS?
This node is on AWS.
So,
Yeah.
so if you do the MSI.
I just want to call out that if you look at the node detail and you look at the org name, this says Chef Solo. So basically, Chef client can run and talk to a Chef server and pull its node configuration in that way. Or it can run something called Chef Solo, where there is no Chef server involved. You're putting the policy on the node and executing that locally. But our purpose today, we're using Chef Solo on these nodes, but it now has the capability to send its data to Chef Automate. So that's why, even though there's no Chef server involved here, we're still seeing the run data in Chef Automate, which is pretty cool. And so just to summarize that node view, it's sort of like that aggregate view of your fleet, everything going on with it. You can start to look at trends on your converges. You can look at the run list and just the status of all those resources. If you want to read more about Chef Solo and what that is, here's a great link in our docs for that page. So we'll keep going through. So today we're gonna be running that in, we're running this in Chef Solo. So we're doing Chef in what we call local mode.
Expand.
So the next command I'm going to have you type, you won't use this command after today. I created it so that, it was created so that just for simplicity, but basically you're going to use this command sudo run_chef. That's just a wrapper command, and all it's doing is telling the node to execute and run Chef client in local mode. That's all this is doing. So go ahead and sudo run_chef. And let's take a look at the output and see how it does for you.
Enter. And then chef again, lowercase. It's not going to show you because it's a password, so it's hidden. So as long as
How are
you
we
type
doing
it
with that
in.
command? Is that running for you?
Perfect. So
Good, you're seeing some
now,
output?
If you
Excellent.
basically just do a touch, something just if you just do a ls,
Just type in ls.
So,
just type ls.
so there's no run list here, and that's why nothing really happened. Remember, test
So you don't have
chef
any other
operates in a test and
controls.
repair mode where it's like,
So
if the resource is already in the state that it expects it to be, it's not gonna do anything. And in our case, we haven't told this node a run list to apply, so there's no updates that happen to it. So now if you go back to your automate page and node detail, and if you take a look, you can see really no changes right now.
So if you go to sudo, run underscore or chef underscore run.
It's sudo run underscore chef.
Yeah, run underscore chef. No page just sudo space.
So let's pass a run list
Run.
now.
Underscore. No, an actual underscore.
So we're gonna do sudo run underscore chef,
This one.
and we
Chef.
are going to tell it, I want you to call the default recipe inside of the audit cookbook. So we're saying,
Okay.
run the recipe from
So
the
now-
audit cookbook,
Now you're
and it's pulling the default
basically
recipe.
So just start doing what you, as you do, and you should do.
Okay, thank you for being so helpful, Dave.
No problem.
That's why we do it. We have all been there. So let's go ahead and run this command, and we're gonna pass in this recipe. How are we doing with this? Thumbs up when you've got that command done? Looking good? Excellent. So let's go look at your converge status again. Let's pop over to automate and see the run list. And we're going to see some new information. This time we're going to see two resources.
Yeah, you, right there. Just open up a tab, put that in there.
And if you now go to the compliance status of your node,
URL on the very top.
you are going to see some failures.
Oh, you have there, okay.
Yeah, your node failed? Yep, you see them?
Go to notes. Yep. So
So that's bad, right? Hope it's not important. It's pretty important. And we can even see why it failed. If we look and see in this example, this issue is related to a SSH configuration, and that SSH configuration is a rule that came from PCI compliance or whatever rule set that we need to be compliant with. So that agency came down and said, no, you must use SSH v2. And so our node is failing on that currently. And again, you can look at there's a detail button up at the top right. And then there's an area for additional information. And this describes the control that we're working with. Remember I talked about how easy to read this code is? This is it. This is the entire code block that says, here's the control referring to SSH. Here's the impact, it's a 0.7. To my org, that's a 0.7 in terms of like how important it is. A simple title, a little bit more wordy of a description. And then the actual code, the actual inspect test, anybody here can understand what it's doing, right? Describe SSHD underscore config. Its protocol should compare it to. That's looking at that SSH config on your box, regardless of what machine you're running. It knows how to look at that detail, whether it's which distribution you're using. Okay, so we had a machine, we ran a test, no issues, it looks beautiful. Now we passed it our recipe, right? And now we see that it's failing our test, our inspect test. So let's cd back to the home directory and do an ls. And you'll notice a few things in there. You've got your births file, you've got cookbooks, you should see your name, see profiles and things like that in that directory. But let's run an ls on our cookbooks directory, cookbooks plural, ls cookbooks. And when you do that, you should notice that we have two cookbooks. One is the audit cookbook and one is the compat resource cookbook. So I'm talking about why we have only those two cookbooks on there and what do they do. So the audit cookbook installs inspec, runs inspec profiles, and is capable of reporting the results into Chef Compliance or Chef Automate, depending on what you have. It used to be a standalone compliance server, but now everything's in Automate. The compat resource cookbook is good because it allows the Chef client to do more without being updated to the latest. It exposes some additional functionality around custom resources, and again, without requiring the latest Chef client release. Let's take a look at the config.json file, right? So let's cat that file and take a closer look. And within that file, just basically, here's where we're saying, I want Chef Visibility Collector. I want to use this particular version of inspec. And I list out the profiles that I want. So you'll notice that I'm going to use the SSH profile. And here's the path to where my profile is stored. If you run a tree profiles command, this should kind of list out the directory structure of these commands, of these controls. And so we'll dig into this ssh.rb shortly and you'll see what that's about. Let's go ahead and run an inspec test. Okay, this is great. You'll see how quick and easy it is to run. So we are going to run inspec exec, and then we're given the path. And the path is profiles/SSH. Remember I showed you that profiles directory and we saw that in there? So inspec exec profiles SSH.
$sign inspec?
No $sign. That's
No $sign. That. Yeah. So how are we doing with that command?
I see red.
Thumbs up?
I see red.
You see red. Great. That's what we want. So let's remediate our failing controls. We're going to run the audit cookbook to verify that our remediation actually worked. And finally, we'll see the node, and we will see that it's compliant now.
If it's red, something's wrong. If it's green, successful.
So how would we remediate that right now? Let's say we didn't have inspec. How would you go and fix the SSHD, or how would you figure out where to change that? Probably have to go and hunt down and find that file somewhere, right?
I asked one of my coworkers seeing if they're having the same problem too.
Yeah, exactly. I mean, you could do all of those things. Chef gives you a really clean, easy path to be able to remediate this. And let's see how we do that. So obviously, option one is you can do it yourself manually. You can write a cookbook to manage the SSH config, or do it manually.
I was going to say, one problem if you do it manually, what if you have that same scenario where you have 60,000 nodes?
Which is not an unlikely thing. Like, we have customers managing 150,000 nodes into one Chef cluster.
That'd be a long night.
You'd be there all night.
Well, all month, actually.
All month, exactly. So again, we went in and see the compliance status in Automate, and we saw that it's, we see that, and now we're going to go in and do the remediation. So let's make a simple SSH cookbook to fix this. All right. So we're going to make a recipe called server, and that recipe's job will be to manage the SSHD_config file. And then we'll also have a local test kitchen set up to verify the remediation that we're going to make. So let's cd into our cookbooks directory, cookbooks plural. able to navigate to cookbooks? And if you get stuck, just holler. Now we're going to do a simple command called chef generate
Cookbook or books?
cookbook SSH. Be sure this is not plural. So we're just generating a single cookbook, and by using chef generate cookbook and then the name of the cookbook, that's how it will get created. Chef generate cookbook SSH.
This is how you want it. And then you put a slash here.
Thumbs up if you've got that cookbook created.
Slash. There it is.
Great.
So CD.
Fabulous.
Tilde is your home directory.
Let's add a recipe now to our
So now you're
cookbook.
there. Now you can
So
chef
when we
generate.
ran chef generate cookbook SSH, it created a structure,
Actually,
a kind
no.
of skeleton of a cookbook
You're
structure that
actually gonna do
contains
cookbook first.
recipes,
Yeah, 'cause
tests,
you
all
choose
of
a
that
head.
kind of
So
structure.
now you can
We
chef
would
generate.
go and fill in some of those details.
Cookbook.
But
So
now
it's
we want to
cookbook.
do a recipe as well within
Space.
that cookbook.
SSH.
And so we will do chef generate recipe SSH server.
Okay, so now we're gonna.
And by
CD
doing that,
into
it's gonna put
So
it inside
CD
the SSH cookbook.
Space, and then, SSH is, if you go back one, you can just hit tab. Yep, hit enter. Cool, and so now do chef generate recipe.
How are we doing? Everyone able to create that recipe?
Instead of just do chef generate recipe, go space down,
Doing good? Great.
space.
Now finally, we're gonna make a template. So this command's a little bit longer, but we are doing chef generate template SSH SSHD underscore config space dash s /etc/ssh/sshd underscore config.
How many people have been exposed to Chef prior to this class? Is this all pretty much new?
Yes.
Yeah.
So a lot of what we're going to do, this is not the bulk of what we're trying to teach you, is this actual cookbook design. But what I'd recommend if you're interested is if you go to the tutorials, if you go to chef.io or learnchef.chef,
Learn.chef.io.
you can learn about a lot of the background about what we're doing here. We're basically setting this up to put more focus on InSpec, but
Yeah.
so right now it's a little monkey see, monkey do, but.
Great, so thumbs up when you've got your template generated. Set. Fabulous. Let's go use your text editor, Nano, Vim, whatever your choice, again, and let's edit this file. We're gonna edit we need to be in cookbooks, SSH recipes, and the one we're gonna edit is called server.rb. So let's edit that file using your text editor of choice, should be installed on the machine, and make it look like this.
Recipes, just type REC tab, tab, see if it finishes it for you.
Nice.
And then server, and then tab. See, and then enter. So now and then go down here, down to the bottom. Just, you can use your arrows, just to go down below the comments. And you just type what you see there. Oh, we're using VI? Yeah.
There's a new thing in VI where it goes into this automatic comment mode. It's really annoying. I just run into this recently. It's a recent update. So the way you do it is you have to just back out the first comma and hit enter, and then you'll be fine. Yeah. So hit enter, and yeah, it's annoying. I swear it's a conspiracy. People are trying to get all the old school Unix people to start using Nano or something. I don't know. That's my 10-hat theory.
How are we doing?
I'm just happy you guys have Emacs on here.
How are we doing with this command? Everyone able to create or edit that recipe file? Are you ready?
Great.
Ready?
Oh.
See, somebody's still typing, that's fine.
Okay, so let's just do this, go to LS. Sorry, LS space S. Yeah, slash, etc.
Yes.
I keep getting this.
Such a file of directory.
No, I wasn't that. Forward slash SSH, SS, tab twice, tab one. Okay, so underscore,
They should be VI and usually.
Yeah, that's the problem, okay. So now you know, that's why I was having you just look at it.
Ned,
Yeah.
if you have a second.
Sure.
We have a typo.
Are you? I should be okay.
Okay, so we're gonna pause, we've got a couple of folks that, just gonna get sorted out on a couple of things, but let's just talk about what we're doing here. Your infrastructure is code, it should be tested just like you do any other code base, right? Anything that we're talking about here should feel like this should be a good practice for you to follow. We should be doing linting, we should static analysis, unit testing, integration testing, compliance testing. And furthermore, we want to give you the tools to really embrace the test-driven development lifecycle. You know, TDD is very much in vogue right now and hopefully will always be in vogue. And what that says is before you write code, you will actually write the test that will tell you if your code does what you want it to do. And you'll do that first. So you write a test, a little bit of code. Test, a little bit of code. You write just enough code to pass the test, right? And then you go on. Okay, and if you can just sort of like get yourself in that mindset, write the test first, then write the code, you'll be a much stronger developer, operations person, whatever your path into IT is going to be. And then, you know, more tests, code review, peer review, these are all good practices. And by doing all of that, that really reduces the chance of failures in production. And so with Chef, we offer you an open source project called Test Kitchen, which it really embodies those beliefs into a tool set that gives you a framework for knowing if your changes are going to achieve the outcome that you're looking for. So with Test Kitchen, right, that lets you have drivers to spin up and test onto Amazon, to Azure, using VMware, OpenStack, you know, wherever your infrastructure is, you can use Test Kitchen to kind of spin up those test instances. Test Kitchen has a number of phases and commands. Kitchen create sounds pretty clear what it does. It actually creates the VM using the driver that you specified. You know, is it an AWS, EC2, Docker? A Kitchen Converge does a few steps. It installs all the Chef DK tools. It copies all the cookbooks that it's supposed to test, and it runs and applies those cookbooks. And then finally, Kitchen Verify, well not finally, but Kitchen Verify allows you to verify all your assumptions about that machine and bring it all together. And finally, Kitchen Destroy actually destroys a virtual machine. There's a command not listed here called Kitchen Test, which actually begins with a destroy, then does the create, goes through the entire cycle, and ends with a destroy. So I always like it to do a good kitchen test after I've been doing a bunch of dev work, because then I just really know continuously that my stuff works and that like I didn't make a change and then forget to test it. And so now let's talk about how do you tell Kitchen what to do. If you navigate to your cookbook directory, you will have a hidden file called kitchen.yaml, .kitchen.yaml. So go ahead and find your directory, cookbooks, plural, SSH, And let's nano or use your text editor of choice to open your kitchen.yaml file.
Can I ask a favor? If anyone is actually caught up, if they have the actual template resource that you've created, if you could put that in Slack for some of us who are trying to copy and paste, put 3 backticks in front of it and 3 backticks at the end of it, and I'll put it in a nice neat code block. So if you can, somebody, if you're ahead, if you can copy and paste that into Slack, that'd be helpful. Yes, exactly.
So I think we're gonna just pause for 2 minutes and we'll walk around and just see who needs help.
Your backtick.
Oh, this
Yeah.
are you?
I'm still with template now.
You're doing template?
Yeah, you got it.
Sweet.
So yeah, just in Slack.
In general?
No, in community, or Cal Poly.
That's.
You can join.
What do you think? Oh, okay, well, Larry joined.
Oh, there we go, okay. But now you know how to do that.
So if you've got your kitchen.yaml file ready to edit, the first change I'm gonna have you make is to remove Vagrant or comment it out and replace it with Docker. So instead of spinning our test instance against Vagrant, we will use Docker.
If you do ls, or sorry, ls ssh space dash.
That's why it's more.
Dash, dash, dash is a valid entry, yes?
Say it again?
Dash, 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 that's a valid entry.
Dash. These things?
No, that's top. No, right above time.
Okay, are you using Nano or VI?
I don't know why those are there.
Nano?
It's
Okay.
a file.
If you
It is.
if you had to look, if you looked
Okay.
at me, that means Nano.
I'm not sure why those are there.
So Nano, type Nano.
The next change I want you to make to Test Kitchen,
Control X.
this is where we sort of describe the test suite, like how many different OSs do we want to test our code against. Sometimes you can write chef code that will, if you run it, it will run the proper way on whichever OS. But in our case, we want to go down to the platform section of your kitchen.yaml file, and we are going to comment out or remove Ubuntu and CentOS, and we will only leave CentOS 7.3. So your test platform here should only read CentOS 7.3. Hyphen CentOS hyphen 7.3.
Enter. Okay, now do kitchen space INIT. That's fine. Okay, now do Nano. Oops. No problem. Control X. Okay, Nano space kitchen. Okay. Got YAML. You can hit tab. Yeah. Okay, now you're caught up. So we just initialized it.
How are we doing?
She's doing good. She didn't have a kitchen.yaml, which was weird, but I fixed it.
That's weird, because that should have happened when she did the chef generate.
Yeah, that's why.
So maybe the chef generate had a typo and it made a different folder.
But I fixed it.
You fixed it. Okay, so was she able to change to Docker and then 7.3?
To Docker. Just there's that one line.
Yeah, the other thing is.
No, no, you should just be able to. Oops, I see yours up here. Here.
You just gotta get.
Oh, crazy. Okay.
How's it going?
Yeah. Now, okay, yeah, we're at the next slide. And so we're gonna go down to platforms. I'm gonna take out these, just replace the first one with CentOS 7.3. Just put a 3 there. And then just get rid of that line on the top. The Ubuntu line.
The third set of changes we're going to make to the kitchen file
And then please get rid of that excess stuff. And put a colon. Okay.
Our test suite right now calls to the default.
I think
We're gonna have it, take that out and put, you know, remove the red, change it with what's in the green, basically. So we're gonna set the run list in this. As well as redirect what inspect tests it's going to do.
So I typed
By the
it
way,
in
I'll
and
be
nothing happened.
providing a copy of these slides. On the VMs that I'm having you use,
Get out of here. So
we can go ahead and leave those up for you for a couple of days if you wanna keep hacking on it. That'd be good?
And then
Great.
one more and stop. I hit Control X. And then hit yes, Y.
So
Yep.
there's like,
Say Y.
there's like velocity,
Yeah, and enter.
or velocity, or,
Okay, that's how you save.
or like mocha.
Nano. So you
Which
just-
those
you
are
go
like,
into Nano, you do some stuff.
testers for
Control X, Y.
JavaScript.
Control X, Y to get
So-
out, yeah.
Does it like check all the code
So
and
now
everything,
you're gonna,
and
do
make
a
sure that
nano.
things are working how they're supposed to?
Space, dot.
Yeah, and
There's
inspect
SSH,
is,
sorry.
it's a couple things. One,
so I go back
you could
one.
think about it around
tab.
like integration testing,
And then
as an
dot
integration
kitchen.
test versus like a unit test or something
Yeah,
like
just
that.
hit tab.
And then a compliance
And then
test.
enter.
And so, there are some things that it is
Okay.
not.
So you're
It's
gonna
not a
change
pen
this to
testing
Docker.
tool.
So just change
It's
favorite
not
to
a
Docker,
like,
DOCK.
Qualys type of a tool, things like that.
Yeah.
But this is the only tool that allows you to write your tests and include them as part of your development pipeline and fail early if there's a problem that violates one of the regulatory rules that you have to adhere to.
Instead of compiling and then testing.
Yeah, I mean, and again, this lets you test it in any context, right on your laptop, inside of Test Kitchen. You can use inspect against your production, like, it's fine.
Can you change this to Delta?
We want to give you a
remove that
tool that
altogether. Yeah,
you
just
can
remove that line.
incorporate as early as
And then
local development.
Okay.
And have that same tool applied throughout,
One more back.
throughout the cycle. So,
And one more.
how are we doing on this
Turn
last
this
set of
7.3
changes to kitchen?
To 2 to 3. No.
Okay, and, so again, we're, in
This
this
line down
last
there where it
change,
says
we're,
center
calling
7.3.
out that we want to run
Turn that to
the
7.3.
SSH server
Nope.
recipe versus the
The last
default
digit.
recipe. And we
Yeah.
want our inspect test to come
Dot
from,
3.
home, chef, profiles, SSH.
7.3, yeah. Perfect. Okay, now you're gonna scroll down. And you're gonna make these changes here. So the name is gonna be server. And then the run list is gonna be, instead of SSH default, it's gonna be SSH : home server. So that default, you just change the server.
You open the Google browser.
And then where it says test by default, you're gonna change that to home, chef, profiles, SSH. Yeah, you're stuck there. Anyone else need help?
Cool. Thumbs up, we're gonna go ahead on this change.
So now that it's done.
So let's go into your cookbooks directory and go into the SSH
Enter.
directory. So we'll
Just
CD cookbooks SSH.
So you can just CD SSH.
CCH.
CD space SSH. Enter. So
Let's
now
run a
you're in
command
the
called
debug.
kitchen list. You always want to run kitchen list from within the cookbook that you're trying to test. If you run it somewhere else, it would be like a whole different kitchen file. Some people use one giant kitchen YAML file to drive all their projects. We typically, or in general, would have one kitchen YAML per project because you would have, then you can have the specificity that you're looking for. And Ned, you can talk too if folks have reasons why they would do one versus the other.
There's a lot of flexibility, but I'm going to throw a little opinionated stuff that you really should just maintain your cookbook per kitchen.yaml
One
file.
kitchen file.
One, and it's
One to
kind of,
one.
later you'll learn, like, when you're working with like Git repositories and stuff, it all fits into a nice pattern where you have one Git repository per cookbook, one kitchen.yaml, and so on, so you can really make sure that you're testing the right things. Otherwise, you're making kind of an administrative mess, in my opinion.
When you run kitchen list here, you should only see one result, and you should see CentOS 7.3. Why do you only see that? Somebody who's going to answer, not everybody at once.
I think it only says CentOS server CentOS because you took out input to and CentOS.
Bingo. That's it. That's exactly why it's not there. And so, yeah, running kitchen list lets you sort of verify that you get your kitchen YAML file the way you want it to, and it's going to have the right result. So let's now run kitchen converge on your machine. So just type kitchen converge. Whole bunch of things happening when your kitchen converge starts.
Whoa, you're right.
Yeah, it's spinning up the machine
Is it normal
in
for it to be
Amazon.
light blue?
Pardon?
Is it normal for it to be light blue?
Yeah, that's fine.
Because I know green is good and yellow is like something's wrong, but I didn't know about blue.
Blue's fine. Oh yeah, that looks great. Right, remember the kitchen converge, it's creating the machine, it's installing everything, it's doing the chef run on it. Special sample for you, because that's the good job. Okay, how's your kitchen converge running? Finished? Still going?
Finished created.
Great. So technically we haven't really written any tests yet, but a passing kitchen converge could be considered a test, right? Kitchen passed, like it converged, it didn't error, that's good. But let's go ahead and start here with our verify step. So go ahead and do a kitchen verify now. Who can tell me what kitchen verify does?
To check to make sure it's legitimate.
Yeah, it's basically, it's going a step further to now what it's doing is looking at your cookbooks and looking at the policy that you're trying to apply and verifying that those assumptions work.
And apparently actions failed.
Absolutely it failed. So we just have a failure, and now we need to make a little change to remediate that. Let's go make another change to our template. And this is where we're going to basically fix the problem of the SSH configuration. All right, so navigate to Cookbooks, SSH templates, and then the file that you're editing, nanoing, or what text editor of your choice, sshd_config.erb. So we're going to edit this file, and you're basically making one simple change to remove this comment, such that it does read protocol 2. Okay. Make your change so that it reads protocol 2, and save your file. How are we doing with this one? Thumbs up? Thumbs down? What's going on? Who needs a helper?
I do.
You need a helper? What you got?
I'm trying to find protocol 2.
Okay, and so did you edit, let's see, where are you? Okay, so let's nano cookbooks and well, you're already in that directory, right?
Yes.
See, can you do ls desk real quick? Okay, good. And then, all right. Okay. One second. So the problem I'm seeing is that you're missing a new cover cookbooks. How are we doing with this change? How's it go? Good? Thumbs up? Excellent. Okay.
Okay, there's kitchen list and kitchen config.
Kitchen.yaml?
No, the command.
Kitchen converge.
Okay.
Okay. So if you've made that change, make sure you save that file and run your kitchen converge again. So we wrote a test, it failed, we wrote a little code to fix it, and now we're gonna do kitchen convert edit. Now we're gonna do kitchen converge. Thumbs up when your converge is finished. The case of the missing cookbooks directory.
Yeah, you had it earlier, so.
But maybe I wasn't looking in the right spot.
So what?
How's your converge going?
Good.
Thumbs up?
Let's go to the bottom. Were you just trying to do a converge?
Let's do a kitchen
Okay.
verify now.
One failure, that's good. So, what you're gonna do is from here, you're gonna do nano. No, just nano, type nano. Space, temples. And then, go back. And then slash, forward slash. And then SSH, just a tab. And then enter. So you can scroll down to where you say,
How are we doing with the kitchen verify?
what is it, a mode 2? Or
Thumbs up?
Scroll down a little bit. You with the arrow, yeah. It's gonna be protocol 2, you'll see in this comment. Yeah, now keep going. Going, there you go. See there, take out that little hash. No, enter. Just go over 1, yeah, not 6, there you go. Now save that. Yeah, you're good. All right, and then just do a change in convert. Yeah, you're good. And then after this is finished, you want to do kitchen verify.
Failure.
Let's see, what does it say? If you scroll up a little bit, there you go. So it didn't like your template resource.
The SSH.
Yeah, so let's see why. Yeah, can we look at your recipe? So if we go to nano, yeah, recipes, so it should be server.
I'm actually
Yeah, hit
in
enter.
between app
So
development
template, do, and source. SSH, oh, SSH. I think you wanted that to be SSHD.
stay out.
Yeah.
But it's interesting so far what I've covered.
Save that.
Sorry, good luck.
And now you should be
Oh,
able
yeah,
to do
I
a
have
new
it
converge.
Actually, I just got it a few weeks ago.
Go back one.
Sparrow.
So CD,
Sparrow.
CD
Oh.
dot dot, yeah.
I don't know.
Yeah,
Someone
from there,
gave it to
kitchen
me.
converge.
As a gift, so, yeah. Cause have you heard of
So the good thing is it gives you a lot of error output, so you can kind of troubleshoot it, fix it, and then rapidly get back on track. And you're gonna be doing that a lot, because we all make
Reddit,
typos left and right.
a walk picking little station, and I ran it for a little bit, and they figured it was a problem.
I first started looking at my first illustrated conference at AppSit. AppSit. In Santa Monica.
Oh, okay. Yeah, yeah,
That should get through too.
How are we doing? We got kitchen converge and kitchen verify.
Well, I was gonna say.
How'd that go for you?
Zero failures.
0 failures, right?
This time I
Okay,
should-
let's do a kitchen test. Remember, kitchen test kicks off the whole cycle, starts with a destroy. So it kills that instance entirely, starts through that whole cycle for you. So run your kitchen test.
Be sure handcuffs. Very practical.
Hopefully I won't use it too
So you can suspect hairpin.
Okay, let me know when your kitchen test is complete.
There we go.
Thumbs up? Great. So you just experienced the magic of test-driven development. Like, how do you feel? How does it feel?
Job, man.
God, you just feel alive, right? Pumped. Oh, yeah. Put that on your resume, test-driven development. So we just experienced that cycle, right? We wrote a test, we failed, we wrote a little code, we fixed it, all of that. And so now that we have gone through that cycle, we have now a good method to test our change by using Test Kitchen. We really have confidence that we know how to manage that configuration in such a way that the inspect test will pass, that we can feel 100% confident that any machine that we run this recipe on will comply. It will comply. So now let's deploy that change to production. So we're going to remediate the change, or the failing issue, with Chef now. So we did it inside of Test Kitchen, now we want to do it for real. So let's go ahead and run this command, sudo run_chef.
Any directory?
You want to be within your
Home directory.
right, from within your home directory.
But it should work as long as you're in your home directory.
Yeah,
It'll find out.
it'll find it. Should we copy these commands into Slack?
Yeah, that's what I was saying. If we could stuck out people. Copy and just link it. Yeah, because you can host it. It's not like you have to download it.
How are we doing with this command? Good?
Finish.
Great. If your command has completed, you should go look at your node in Chef Automate and take a look at that and see how the progress is and see the converge status inside of Automate.
A lot of you will notice that you have, like, it'll say something like 1 of 3 resources updated. What this is saying is that, we made a change. You'll notice if you do this again, like if you just run the command again, it'll go really fast, and it'll be 0, 3. And basically, Chef's not going to make a change unless it needs to. It does this kind of test and repair cycle. So if everything is actually in the desired state, it's not going to basically do anything. It's just going to test it, make sure that everything's good. And this allows us to run the Chef client over and over again without, having any kind of instability.
Yeah, Yeah, so run that command, take a look at your node status inside of Automate.
Yes.
So what does this mean?
And if you click on the compliance status of your node, it should be all green.
That's your node right there?
So my node is, there's a check.
Oh, is your node green? We can't count for everyone. We can only count.
Oh, absolutely.
Yeah, and so that compliance status shows green. You're green on your SSH version config now.
Where's that?
Full green.
So your 2 of hearts, you said?
No, mine is,
So.
check.
So that was pretty awesome. We had a node with really nothing going on. And we were given the command, it's time for you to manage the SSH config on this machine. It has to be version 2. It cannot be version 1. And we achieved that by installing the Chef client and the Chef on that. We installed Chef DK, so we have all our development tools. We on that machine, we gave it a run list and we told it to use the audit cookbook, right? And inside of that audit cookbook, we created the recipe specifically and the test for the SSH config. And then we test all of that inside of a Docker container to prove that our SSH config would result in a passing inspect test, and therefore its compliance status would be green in Automate. Okay, and through all of that we saw that inspect is super easy to write that simple little test, and we can run that test locally, or we can run it against another machine. We can run it against another Docker container. We can run an inspect test anywhere. Windows against Linux, it doesn't matter. As long as you have SSH or WinRM access to that node, or that the password for the Docker container, you'll be able to run an inspect test against it. And so that's kind of like the heart of inspect, inspect.io. And if you go to that website and take a look at the documentation, you're going to find all of the resources that you can test using inspect. You can test security groups in AWS. Imagine being able to know that the machines this department is spinning up are in the right security group. You can test things like the security of your SQL databases. You can test a whole bunch of things. All of those resources that you can write a test for in inspect that you can control are in the documentation. So where we are now is basically it's 4:30. We've got another 30 minutes. And what I'd like for us to do at this time, I have 3 kind of optional exercises that we can do. And I'm going to flip through them real quick, and you just decide which one you want to do, or nothing. It's up to you. But I'd like you to do at least one more quick test, quick experience of what you can do with inspect, because this is also going to familiarize you with how to use the documentation, right? As an IT person, as a sysadmin, computer science, whatever your jam is, you need to be really skilled with documentation and finding it and all of that. And so let's take a look at a few more hands-on exercises that we could do very quickly to write a test. The first one asks us to write a control that tests for the existence of a certain file. We are saying etc ssh_host and that the RSA key. And we're going to write a test that that the key contains these words, begin RSA private key. So we would use our documentation to go try to figure out what is the language, what command we would write inside of inspect to do this test. So that's one little fun lab we can do. This one might be more interesting for you. We want to make sure that root is not enabled on a machine, right? That seems like a good security test, right? We definitely want to disable root access on a box. So this example offers you, mentions and it describes this permit root login parameter, and whether that root login can log in using SSH. And so we want to disable root login over SSH this forces them to use an individual account, then they can use Sudo if they need to. And so basically, you would just, if you want to do this lab, you're going to go back into your ssh.rb. So you're going to find this control, and you're going to basically add, you're going to use the documentation to figure out the words you need to write, to test this. This is one option for us. This one's kind of fun too. Have any of you heard of DevSec profiles? DevSec is I'm trying to think of their website to take a look at it, but basically we can go onto the supermarket and see that a lot of companies have shared profiles that they've already written for you. Like, you don't have to rewrite the world, we've done a lot of that work for you. So you can check out the supermarket and take a look at the SSH baseline profile. And you could run this test against your machine, or you could just write a cookbook that'll do some of the fix the failing controls. Because when you run this, it's gonna fail. You're gonna have some tests not pass, possibly. And then you could write a recipe to resolve that. You could also try the SSH hardening cookbook. There's a whole bunch of different ways that you can start to really make a meaningful difference in the security of the infrastructure, okay? Center for Information Security, they publish all of these rules. Guess what? InSpec lets you use all of those rules and download the CIS benchmark tests. So here's the additional controls you can obtain here. There's so many things that you can do with InSpec. The commercial product that you pay for with Chef Automate gives you that entire rule set written for you and a whole bunch of other things. But the free part, the open source aspect of InSpec, is that language that lets you write a very simple test to describe the state of that resource. So you can really make a lot of impact on your organization, even with the open source project as well. You can, write tests that make sure that it passed Chef Style and Food Critic, things like that. So I want to talk about some resources too. The website, inspec.io. You're already in the community Slack channel. Welcome to the chat. Welcome to Chef Friends. We have our mailing list called Discourse. That's a great place to sign up for updates so you know when product releases come out. You can read the release notes. So many great bits of information on Discourse. And remember, we have compliance profiles that other orgs have shared on our supermarket. And then the open source, it is an open source project, and so if you head out to github.com/chef/inspec. As today was your first sort of probably introduction to InSpec, I have a little favor to ask of each of you, is to go through the tutorials, go through the website. If you find even a sentence that could be written differently that would make it easier to understand or clearer, or if you find even a typo, any change that you submit, and if you submit a PR pull request for, I will merge your change if it's a good change. And when you make a pull request to this project, that is powerful because you are contributing to open source software. And I want you to know that open source software is driving the world, and Chef is an open source company, and we value your input and value your contributions. And when a community person takes the time to, fix a little line of code, something like that, makes a big difference, even if it's a small change. So my ask of you is to make one pull request against this project sometime in the next 30 days.
So what we basically just did today?
What you did today is learn about managing how to test for and manage the state of the SSH config on a I think it's a CentOS box that you're.
How many, just out of curiosity, how many people in here are pursuing maybe a job in security someday?
Cybersecurity?
Security, yeah.
Just barely started.
Yeah. how many people are more like looking to be operations folks or work like, as far as like developers or
DevOps.
Yeah. So traditionally, in the old school way of thinking, I wish this was always in the past, but it's still kind of going on. We're working on it. You guys have been pitted against each other. You guys have had different objectives, different alignments. Security, you're concerned with just making sure everything is, tight, making sure that there's no, vulnerabilities. That's the, biggest concern. Developers and such, you want to get as much code out as fast as possible. Those are juxtaposed agendas. And so what we're doing is we're giving you guys a common kind of tool set where you can turn all the definitions of what makes a system secure into code so that developers and security people can get along, and next thing you know, you can go bowling together and be friends again, right? And that's kind of what this is kind of about. You basically looked at a security profile that was failing, based on an SSH requirement, and then you use code to remediate that. And so typically what's going to happen is a security team might manage all these profiles, might even create their own profiles, and hand them off to a developer and say, make sure that these all pass before you submit this code. And that happens now far to the left of the problem, rather than after it's already in production and we're having a big, storm about it. And that's what we're kind of trying to do, is move this as far to the development stage as possible and stop having these, catastrophes after something's already in production. So, that's kind of the moral of the story.
Yeah, I just pulled up the site to look at all the list of resources that you can test against. Docker, IIS site, Postgres config, security, Windows password. I mean, there's a lot going on here. There are some tutorials on the site as well. These were written a little bit ago, and a lot has changed in the project since then. However, I still think they're useful. Annie Hedgepeth, a community member, wrote this, and now she's like internet famous because we put her tutorials on our site. So if you contribute something, like this could be you. Lots of great information on the website. What else was I going to take us into? Yes, thank you. Learn.chef.io. So learn.chef.io is such a great resource because it has tutorials, a whole bunch of skills libraries, and I do want to call your attention to training and certification. So first of all, Chef is now offering certifications for your chef skills. You can take a course on linuxacademy.com. I think it's free through June to sign up for the community edition of linuxacademy.com. They offer 2 courses that you should know about. The first one is the Basic Chef Fluency course. And by taking that course, it's 5 hours of videos, and they give you like a lab machine to use and everything like that. At the end of that, there's a place for you to take a practice exam. And if you pass that practice exam, like you're pretty much ready to take the actual test, which I believe is $75 to take that first test. I have some discounts and things that I can connect you with if you're a self-directed, driven individual and you can go through those tutorials. I do recommend the Linux Academy course, it's great. And the other course it offers is the Local Cookbook Development Badge, okay? When you achieve both of these, you're basically a certified chef developer. There might be one more badge after that, but this is important. Why? Because employers want people to know Chef. They want people to know Inspect because these are the tools that are hot right now. These are the prevailing best tools in the industry, and companies will pay you very handsomely to know these skills. And when you obtain these badges and pass your exams and put that on your LinkedIn and your resume, now you're talking. Because go to glassdoor.com, look up chef skills. Guess what the median salary is for someone who knows chef? Guess.
80,000.
200.
skills. The median salary for someone with chef skills is $130,000. Now, like, this isn't something you're gonna get to that, like, after taking a test, right? You definitely wanna use the product, learn it, actually build yourself a lab. You can do so much with our open source tools that are no cost to you. Again, Linux Academy Community Edition, before June, you can get take all those courses for free, and take your practice tests for free within the construct. They also have this on Udemy or something, but I think there's a cost there. But Linux Academy, take those 2 classes, see if you both have a talent for the tool and it appeals to you as to, and that you see the vision of the skills that we're going to give to you and what that makes you in terms of how attractive that makes you from a developer's perspective, from a hiring perspective. And so learn.chef.io is a great resource. We want you to have that. I highly encourage you to explore training and certification options, just because it makes you a stronger candidate just from a DevOps perspective, and things like that. So learn.chef.io is good. And let's see what else I was going to leave you with something else. Yeah, the community tab on our website offers a link to all of those things. One thing it offers too is an events button. And so if you click on that, it is going to show you, oh look, you can come to Cal Poly's Tech Symposium event here. Look at that. So basically you can find upcoming events related to InSpec or to our other products by going out to that site. And with that, we just have really like 15 minutes, 12 minutes left. So I'd like to just kind of open this up to you as to if you want to do any more of these labs. If you want to just open it up and we can do Q&A, we can talk about anything you'd like. We're here for you. And like I said, I'm serious about that PR. And when you do that and you ping me in Slack to let me know you maybe want some coaching on your PR or something like that, when you do that and complete that, I am going to ask you for your mailing address and I'm going to send you some special swag. You're going to get an InSpec t-shirt and some like very hard to get chef swag, which is cool. So that's my promise to you, is cool swag and Starbucks card. But I want your PR, I want your opinion on this project. And if you're along that 30 days, make sure you're in the Slack channel, asking questions, learning from other people in the different Slack channels. But you know, be sure to do that because that's where all of our developers are. They're all in there answering questions all day long, as well as the chef community, which is, I don't even know, it's so big. People are using Chef all over the world in companies that you have heard of, not heard of. It's everywhere. It's everywhere because it's that good.
Yeah, I encourage you guys just to look in the general channel of that community
Sure,
Slack
that's a good one
and
too.
just watch it for a little bit, see some of the questions that are being asked, some of them may be questions you've had. And sooner or later you realize that it's a really friendly place, and if you ever come up with the questions yourself, you can definitely feel safe to ask it there.
My last request is one for feedback. If you have a chance, don't leave it to next week because you'll forget. But if you have a chance in Slack, just send me a direct message. I'm UberGeekGirl in Slack, and send me a direct message. What I want to hear from you after our time today, first of all, thank you again for spending a few hours with us. It's been a lot of fun for me, and I appreciate your time and attention. Share with me something you learned today, or a possibility that has now come up for you in your mind based on what you learned today. Something unique, you know, any anecdotal comments that will just help me get a feel for what this meant to you. Was it helpful? You know, just anything. Just give me some kind of feedback. And if there's something that is negative, like, Jessica, your shoes are ugly, like, you can tell me that too. It's totally fine. I'll probably wear a Converse next time. I don't know. Yeah. Follow me on Twitter. I'm UberGeekGirl on Twitter. I mostly don't say political things. I mostly talk about DevOps and tools and Chef and things like that. Ned Harris 77. What's your Twitter?
Nedward. So it's
Nedward,
like Edward with an N in
N-E-D.
front of it. So
Nedward.
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 Yeah.
So follow us on Twitter, ping me in the channel, and then like 30 days from now, like holler, let me know what's going on. And you know, just again, thanks for the time today, and please let me know if you have any questions. I'm around most of the time. Thank you.
I was also going to say, in community Slack, you could just find me at Ned, N-E-D. So I'm in that community Slack
There
channel.
you are, Ned.
Yeah.
What's up, Ned? Yeah.
So not too hard to just NED if you have any questions.
That's me. Ta-da. Okay. Cool. I will post the slides in this channel, and I'll just do that right now. Let's see. Can I do that? Yes, I can.
But only because I will say that.
If there's
And again, let me know if you guys have any questions. Yes?
I have a question. I was wondering if you could look at something.
Oh, okay. Is something just a little error or anything you wanted to share?
I don't know if you remember me, but
Yeah.
I said that I went to that together.
Okay, yeah.
And I was like, you're right.
Thank you very much, Mrs. DeVita, for being very helpful.
You're welcome. Thank you very much.
That was very informative.
Was it? Good.
Oh,
Good.
wow.
I'm glad you were here.
Honestly, like the first time I've done something like this.
Awesome. Fun. Love it. Thanks for coming.
That's a big container.
Yeah, let me give you, I have a chef sticker for you.
Thank you.
Yeah, you're welcome. Awesome. I love that when a plan goes together. Okay, I updated the slides.
Here's my business card.
Oh, fantastic. Thank you. Thank you, Hector. Awesome. So you're new, when did you start at Cal Poly?
Actually, I'm not a student of Cal Poly.
Okay.
I'm a student of CSU San Bernardino.
Oh, nice.
I just came here because I got an email from InfoSec in regards to the conference.
Fantastic.
And so it was free. I was like, well, might as well go.
Yeah, absolutely.
Because actually, I only live 10 minutes away from here.
Oh, that's so great. Oh, I'm glad. Very cool.
I had no idea Cal Poly had tech.
Oh, God, yeah, Cal Poly is, like, this is the place to be.
That way it's not communicating.
Yeah, sure you wanna come to Cal Poly?
And that only captures it, you know.
That's kind of hard because
Yeah.
the whole process.
I understand. Yeah, but they do tons of programs out here, and, you know, I'm sure they'd love to have you.
I'm literally just calling PowerShell and then running.
This is yearly.
Yeah, so we do the Tech Symposium every year, and then, you know, you guys have like tech talks on Tuesday afternoons, so.
Wait, this happens every year at Cal Poly?
Yeah.
Nice.
Yeah, our club puts it on.
Yeah, good stuff. Right on. Well, thank you very much, Hector. Thank you. And then be sure to say hi to Ned too, because I know he was happy that you came as well. Let's see.